they tell us that the atmosphere is moving in lockstep with the Earth, right? And we have different latitudes on the Earth.
They
So
don't
just
though. They don't even
imagine that.
say that. They don't say lockstep anymore. I don't know why people. I know that that's the narrative that people think mostly, but they don't even say lockstep because they can't. They can't claim that. It
What do they
wouldn't work
say?
with fluid dynamics. They just say that it's more or less in lockstep, whatever that means. That's just a vague, like,
But then
estimation
we
word that makes
then we
no
should be
sense,
able to
anyways.
feel it. If it's more or less, then we should be able to feel it, right?
Yeah, you'd be able to know, like, with the difference. It's just a way of, like, passing it off. It's the one thing that just debunks the globe emphatically. There's no coming back from it. If everybody just realized that they can't claim that the fluid dynamics wouldn't work. It would have to be moving faster as the altitude goes up. The top would have to be moving faster than the bottom, and you can't even treat molecules of air as a solid body, anything kind of rigid. You can't even like compare it to water. There's no way to say that all the molecules of the air are working in one direction when we know we have winds in all directions. You can't separate the wind from the atmosphere. The atmosphere is not even said to be in lockstep, and the planes aren't said to be bound to the atmosphere. So like the whole idea that it would just keep the plane in sync as the tangential velocity goes up or down towards the equator. So the plane would never, ever, ever be in sync with the ground that the pilot is treating as stationary. That's it. The globe's over right there. If everyone realized that and just knows that they're not claiming the lockstep atmosphere, even if it was lockstep, it still wouldn't work. The plane slows down in the opposite direction.
They
It would never be able to land, period.
they do claim lockstep. It's just that it's not 100% in
I still
lockstep. Like
claim
everything
lockstep.
else, there's still like some wiggle room.
Wiggle room. Yeah, they need wiggle room.
Well, no, it's in
Well, when
aggregate,
you're landing
right?
if you're
Figuratively
landing a
speaking.
No,
if
it's
you're
not
landing
wiggle
a
room. It's
plane,
aggregate.
wait, if you're landing a plane and the pilot's treating the Earth as 100% stationary, there's no room for wiggle room. He treats it
No,
as
I'm saying
100% stationary. That means he has to
it's
be
not a.
going eastward at exactly the same exact. So much so, not more or less. So much so, the same exact speed as the rotation, no matter which way he's facing. The plane would have to be moving in that vector eastward,
No, I get what you're saying.
regardless of its forward motion. That's the thing that
Same
people
team,
usually
guys.
don't
Same
get about
team.
it.
They don't have a cause for why it's in lockstep, but they do presuppose that the atmos is in lockstep or in
Sure we do.
equilibrium with the
They say
surface
more
of
or
the earth.
less. They say more or less.
And
It's
you
just
could still
momentum.
have the system overall be in equilibrium or in lockstep with the surface of the earth and still have dynamic winds.
But you can think of it that way, but you can't
Exactly.
have an actual lockstep with dynamic winds. It can't actually be in perfect lockstep because of fluid dynamics and the
No, you can.
absurdity of thinking that it
No,
would move like a rigid body. Physics doesn't allow it to be in lockstep, literally.
no. Like you can actually show this hypothetically speaking. I don't believe that's the case at all, but
I know you
it
don't,
is
but
possible to have.
hypothetically, even it wouldn't work. I mean, you can
It,
think of it as
it,
an imaginary system that defies all physics. Sure, you can think of it that way.
in a sphere, it's increasingly difficult
Well,
to
no.
actually have something like that happen. But you could have like a cabin, like a train, right? Because I used to be a skeptic at first until I seen it. So you could have like if you're in the subway, right? Within that atmos, inside one of the subway carts, right? You could have the whole air inside the subway cart is moving at 60 miles per hour, dude, following the train's trajectory, right? So all the air inside that cab, right, relative with the surface of the earth is moving at 60 miles per hour. Yeah, you could plug in a fan, or you could have one of those battery powered fans within the cab itself, so you could have both the wind that's in lockstep with the train, and yet have dynamic wind with inside that cab all at the same time.
Right. Now that's just one way of thinking of it, right? That allows you to like then somehow like attach it to the whole idea of like the the larger atmosphere with the ball Earth and everything. The one thing that comparison doesn't have is a tangential gradient, right? You don't have a spherical nature to it. It's kind of like they do with like you could be, on a plane and you wouldn't feel like you're moving at 500 miles an hour, but you actually are. So it could be just like the Earth, where you're moving 1,000 miles an hour and also going around the Earth. The sun is 67,000 miles an hour. As long as we attach the idea of no acceleration to it, then you can just believe that the same exact way. But it's actually a non sequitur.
You're right. You're right. You're right. And
You're
I'll
getting
explain
it.
why. I'll explain that real quick. I'll explain that. So the difference between the train, right, and the globe is that the globe is spinning, right?
Yep.
So there's
spherical with a
tangential
tangential
velocity
gradient.
and it's spherical. So you not only do you have tangential velocity, you should have a tangential gradient as you
Yeah.
go up in elevation. Now,
Yeah. And that doesn't work either.
Now, when it comes to fluids, right, like gases and liquids, the tangential velocity should be decreasing as you go up because it's not physically connected like a rod is physically connected to the surface of the earth. Like if you were to stick a steel rod from the surface of the earth to the carbon line, that steel rod is going to keep its tangential velocity, right? Because it's fixed.
Right.
With fluids, you
Because
don't have
it's solid.
that, right? The
Exactly.
torque wouldn't be preserved because you have fluid dynamics that you have to contend with. You should have a decreasing tangential velocity as you go up because you're losing energy because it's not physically connected.
Thinner atmosphere.
So how do you rationalize that on a globe, especially and in the train you have a container, right? So the air inside the train is being contained. So as the train moves, the back wall is pressing against the air inside the cab. On the globe, there is no wall. There is no container. So how do you preserve the energy?
Yeah, it wouldn't work.
Yeah. What do you mean by losing energy as it goes up? It does. What do you mean by losing energy as you go up?
Yeah, because fluid, right? Unless the only way that it would be possible to preserve the tangential velocity and the energy is if it was a solid, right? If you had a solid or maybe even gelatin substance, something that is a lot. Even gelatin, I don't think it would work. Yes, you need a physical. You need to physically attach to the surface of the earth to transfer that energy, the conservation of momentum, all the way to the carbon line. You don't have a physical connection. You have air, right? So how is the friction, how is the energy being passed from the surface of the earth to the carbon line?
Yeah, and calling it fluid dynamics is generous already because it's gas.
What do you mean by
you can't treat gas molecules like a rigid? You can't treat gas molecules like a rigid body, let alone fluid. But yeah, fluid dynamics alone wouldn't let it work.
You don't understand what I'm saying, Matt?
Fluids in physics just. No, my question was, what do you mean by losing energy?
With every foot of elevation change, right? You're gonna have a lag. Fluid dynamics, you would have a lag. With every layer that you go
up, based
on
what?
Boundary layer. With every boundary layer that you go up, there'd be a lag because of you would be losing energy due to the conservation of momentum. You don't have a physical connection.
Right, losing energy to what?
The energy that's being transferred from the surface of the earth due to its rotation, that energy is going to continuously be lost with every foot of elevation. There'd be a drag, there'd be a lag.
So what is causing this drag? Like, what is it dragging on?
Just for the simple fact that you don't have a direct connection, a mechanical connection, like a physical connection to the surface of the earth, right? You don't have like a steel, like if you, for example, if I were to stick a steel rod, imagine this, if I were to stick a steel rod from the surface of the earth.
No, I heard your example.
Right? So that steel rod, whether you're at the surface of the earth or you're at the carbon line, it's preserving its tangential velocity, right? With fluids, you don't have, with fluids, you don't have that. With fluids, you would lose the energy.
Even with a rod, right? If the bottom is being pushed, right? Nothing's really pushing the top, right? Unless that thing has gained momentum in aggregate, the whole thing has gained momentum. Then the top will be moving in a way that preserves its perpendicularity to a sphere, right? If you don't have that, you just start spinning the earth underneath it, then the front, it's going to start tilting backwards, right? As the floor moves out from under it. So in both cases, you would need the same thing. You would need the conservation of momentum. You would need that momentum inherited from the get-go.
No, dude, that's not true, bro.
You'd have to treat gases like they could be like just like the surface and just be in perfect sync. But gases don't work that way. You realize that,
You would
right?
have to, yeah, you'd have to pretend that the
No, do
gas,
you not
right?
understand what I'm saying with the rod though? Like, where do you disagree with that?
Yeah, I mean, there could be a nominal loss of energy only because, I mean, we're dealing with extremes, right? You couldn't even stick a
Again,
steel
I don't know
rod.
what you mean by
Doesn't
loss
have
of
the
energy though.
it doesn't. It's a hypothetical, dude. Obviously, you can.
Yeah, I
It wouldn't
understand
be
that.
possible physically. The tense. Okay, so what? Why are you asking me these things, dude? You don't know the difference between a solid
Because
object and a fluid.
everybody knows the difference between a solid object and a fluid. My question is, where is this energy? You keep invoking this loss of energy thing. I don't think that's the right mechanism here.
Bro, all you need is a blender, right? You could see this in action. Now, Grant, your argument in your globe model, the argument is after billions of years, billions and billions of years, that the atmos became equalized from the surface to the carbon line, right? That it
No,
reached an
no,
equilibrium over time. That is your rationale.
no.
That is your rationale. Yes, it is, dude. Yes, it is.
No, it's not.
Over
You're telling me
time.
my argument? How about I tell you my argument?
Yeah, dude,
Okay,
I'm still
yeah.
How
Go
about you
ahead.
struggling with it.
don't?
Go ahead.
Wait there. Go ahead. Tell us your argument in a very concise and specified manner, right? And then we'll address whether your argument holds any water.
Sure. So it seems like the misconception here is that the up at the Kármán line or wherever you consider space to kind of start, so to speak, there should be some sort of drag that's keeping the atmosphere from moving in lockstep with the Earth, right? With the Earth's rotation. Being a vacuum at the tippy top, there's no friction there, right? There's nothing like you would have on a train, for example, in an open box car. You would have the top, you would have the train moving through the air, right? And that top layer of air that's not in the train would be sort of drifting off the air inside it, right? So you'd have these whirlwinds at the top of this box car, right? That would be the
That's not my
still
argument.
versus moving friction. I know that's not the argument, but that's the implication of the argument, right? That
I'm
there's
not just
something
talking
that
about
should
drag, dude.
cause a loss of energy, as in friction, as it. Well, then I don't know what you're talking about. Like I don't know what
It's
other
not just
mechanism would
drag
be
that you have to
causing a quote
contend with,
loss of
bro.
energy.
It's with every foot of elevation change as you move up, there's a greater
Lower
radius, dude.
pressure.
Right? You understand how circles work? With every circle as you move up,
I
that's a
do, yes.
larger and larger circumference. You have to not only do you have to overcome the drag, right? You have to make up for the increased circumference to actually equalize the Kármán line
Hmm.
to the surface of the earth. Where are you pulling this energy from? And not only you're dealing with a fluid, dude. Fluid dynamics. It's not a solid, it's a fluid.
Yeah,
Mm-hmm.
we've established that, yes. So you're not talking about a loss of energy exactly. You're saying that you would need an increase of energy to keep that in quote unquote lockstep, right? I'm
Well, you
just
would
trying to
need a
lock down the
solid
language,
rather
right?
than a gas. You'd have to have like a solid body you're dealing with, not a gas,
Yeah.
which would never work as a solid body.
Well, that's
But they have to imagine it that way, and then say that fluid dynamics is also real, and it wouldn't really work, even though we think of it as working, because we all have to believe we're on a globe.
Which again is a presupposition already that the
I think
globe
you got
even
like 3
exists.
steps ahead of.
The way that you guys were able to rationalize it is using the vacuum of space and then a billion year
Mm-hmm.
time scale. So over billions of years, and within the vacuum
I
of
don't think
space,
it's a matter of
the
equalization,
the
though.
uh, the, the atmosphere reached equilibrium. The Kármán line reached equilibrium with the surface of the Earth. That's your rationale, dude. In your model
No,
to keep
I
it
don't think it's
together.
a matter of
That's your ad
no.
hoc. That's your ad hoc reasoning. Yes,
I
it
don't think
is.
it's a matter of equilibrium. It's inherited momentum.
Dude, you'd
It
be
doesn't. It
better off
doesn't
trying
matter
to
how much
explain
time
this
you
on
have.
a
It's
Charles's
once it has
law
it,
at
it
this
has it.
point. Like for real. You would literally be better off trying to explain this with Charles's law. And even there, you have no weight.
Dude,
It's
is
called
that the
Jack and
villain?
It is indeed.
What's
called
up?
Jack.
What's up, brother? So
So Jack and
manufactured.
the Beanstalk Law. Have you heard of Jack and the Beanstalk Law?
Mm-hmm.
So if you know that
What were
story,
you
and
asking?
if you imagine, this is the way to understand how it works, is if you imagine a giant beanstalk, and you've got that 90 degrees straight up, and you're on level ground, like with perspective, that's basically just how you could apply the same scale ratio to what they showed the NASA and Elon Musk rockets going up. People say it looks like it's curving over, right? It looks like it's not going straight up. But if you carefully go back and you take a look at those videos of rockets going up and then looking like they're curving, take a look, just ignore the smoke, the back end, and you just look at the rocket, and you can get a ruler and you can go over the video and you can see that the rocket follows a dead straight path. And it's just an illusion. People are stuck on that one. It's not true.
Is that what you were going to bring up when you first brought this up, Carlos? And I started going off about it not being a lockstep. Is that
Yeah.
why you mentioned it to begin with?
Yeah, because what I'm trying to show is that the smoke coming out of the rocket, which is going, because they tell us it's going straight, and I believe it is going straight. But the thing is that it's exposing what the atmosphere is doing, whether or not it's in lockstep. So if the atmosphere was in lockstep, the smoke coming out the back of the rocket shouldn't make that curved line in the sky. It should just be straight if it's in lockstep.
It should be relative, yes.
Kind of like we used to one of the old flat Earth memes was like you're showing the smoke coming out of the engine of a train, and how if we were actually spinning, then we would see that same thing going on with everything. There would be trails because of the Earth spinning, of course. But then what you're saying is that they're claiming there wouldn't be trails because everything moves in lockstep, even though it has this independent motion. Like clouds can drift north, south, east, or west, but then at the same time, you have to believe that cloud is being it's in perfect sync with rotation with the ground below it. So it's moving 1,000 miles an hour if it's at the equator with the rotation, yet drifting slowly in any other direction at the same time to give us the illusion that we're stationary and it's just drifting. And, but no, it's moving along with us at 1,000 miles an hour, yet drifting slowly in any direction according to the local winds. Think of how absurd that
The
is.
other thing, though, the unfortunate
Yeah, they're getting it.
understanding that comes out of that scenario, though, there is one thing that most flat earth are.
Oh, you cut out. Was that me or you?
Were you
No, he
gonna
cut
talk?
out.
Were you gonna talk about the gas pressure gradient as we go higher, right? And with the gas pressure gradient, that there's going to be less air molecules, right? All of it's created at surface level, right? Created via the sea, via the different trees, all of these different things. It goes upwardly, right? We understand this in a crepuscular almost fashion, right? It's omnidirectional, and then all of these individual air molecules in relation to one another, like in proximity to one another, effectively, like if you were to shoot a shotgun in the air, right? Those pellets in proximity to one another as they grow in height would be further apart from one another, right? So, what is it that you're exactly claiming manufactured that happens at the upper echelon of this atmosphere? Because the
Was that for
story on
me?
that, yeah, it is. I'm nearly finished, but the story on that's actually changed because when we hypothesized exactly that, well, with the moon being exactly 1/4 of the Earth's gravity, right, and it being basically skating along, because obviously previously claimed that, 26 or so men had been to space, right, on the moon. Well, the claim then became, well, actually, has any man ever been to space when we pointed out very aptly, which was that with 1/4 of the Earth's gravitational force with the moon, if we take gravity to be what you say it is, right? Well, then what you would have would be on the upper echelon of the atmosphere next to a 10 to the negative 17 taut vacuum. What you would have would be an entropy aiding machine as the moon rotates around it, right? You also have a pulling vector as well, right? You have a sagittal line of that moon and a sagittal line of this Earth, right? You have salt water apparently affected by that same moon. So you would have a tidal wave as well that would follow and go all the way around the Earth, right? In lockstep with that very moon. But then magically, NASA eventually, as we say to them, this is an entropy aiding machine, they just extend the atmosphere past the moon itself, right? So again, don't worry, it's all good. Science is always growing, it's always evolving, right? Well, how can something be truly scientific if it cannot be, like, in any way, shape, or form propelled or pushed through the scientific method? Tell us how we manipulate any of these variables to confirm any of these factors that you claimed originally. And then how is it that you've reneged on that position? And then now we're talking about the Kármán line and what would occur at that point, right? While we also have all the other orbital different, let's say it's like wandering stars, different parts of the solar system, the very different places that apparently hold us in lockstep with the barycentric orbiting sun itself with Jupiter, right? In a non-existent center of mass in which we apparently, as a heliocentric model, actually rotate and orbit around, right? How is it that you can say that with all of these different vectors, with these large bodies, would also have no entropy aiding effect on the Kármán line? Would you go ahead and explain that to me?
What am I supposed to? That was like a 5-minute rant of I expected
That was a shit sandwich.
Like what are you asking me exactly?
Yeah,
that was
That was a shit
wild.
sandwich. They only extended the Kármán or the atmosphere out past the moon because of the Van Allen radiation belts. That's how they get away from that problem. They can say that it's not a health issue. It wasn't a health issue for the astronauts because there was a little bit of minimal radiation effects that they had when they went there because they already claimed that they did. Obviously, they were on camera saying that they saw shooting stars going by here and there when they closed their eyes.
Yeah, but when did that happen?
Outside of
Mitigation of the Van Allen belt. Let me just real quick. The mitigation of the Van Allen belt has nothing to do with the quote unquote atmosphere extending all the way past the moon. When they say the atmosphere extends past the moon, there's some nominal amount of air molecules out there, but it's not the atmosphere like we think of it as
nominal,
we breathe here, right?
as in measurable.
There's barely any of it.
Like there's data to show it.
Measurable.
As in it exists, but it's barely there.
Oh, so you pretend I didn't know what to say, what I said, but you actually did understand what I was saying, right? And how old is that?
I was responding to this other guy. I didn't understand what you were saying.
Well,
like you said a lot.
Yeah, I did say a lot, right? Because at the end of the day, the story is continually changed, right? That was kind of the point. You get a clusterfuck when you create a clusterfuck of lies, right?
You call it updating, we call it revision.
But you also get it. I know that, yeah. That's fine. But I don't see any contradiction in those updates. Like maybe you could point one out to me.
Yeah, like the James Webb telescope spending galaxies that are at the wrong size in the wrong place.
You can't treat gas like a solid. That's one of the
real quick, you mentioned...
Has any man been to space?
Sure, no one does that. You mentioned entropy aiding device. What does that mean exactly? What is an entropy aiding device?
Machine, right? Like, again, it's not an actual
machine. Sorry.
Listen, we can't even define what the moon is itself, right? We're just talking about the simple fact that if you had something, right, that had, again, this is about proximity to the upper layer of the upper echelon and upper layer of the atmosphere itself, right? In proximity to those gas molecules, the moon itself, with its 1/4 of the Earth's gravitational pull, in proximity, if you work out the mathematics on this, it in relation to proximity to those upper layers of the atmosphere would have a greater pull. Thus, it would, as it orbits, create what? An orbital line, right? Where there would be a pulling vector from the sagittal of that moon toward what? Toward what's beyond it, right? It doesn't just go to the face of it and stick to it, right? It's going to go past.
Have you done the math?
Yeah, the math has been done. There's a reason why.
No, have you done the math?
Revamped, my friend.
I didn't think so.
He's wondering if you
Also, if you do the math with 1/4 gravity,
wait, hold on, wait. Like the question, hey, Crack Villain, what's up?
Gravity.
Hey, Crack Villain, I think what they're asking is, have you looked at the kinematics and then imagine that the dynamics would also work?
Yeah.
That's what he was asking?
That's not quite what I was asking. I was asking him if he actually did the math that he was talking about, because I don't think he understands the math he was talking about. But he could tell me otherwise. So
what you're claiming is that effectively gas molecules that are skating exactly right next to 1/4 of the Earth's gravitational force, the claim that you make is that gravity keeps the gas molecules here on Earth, right?
Where in my question did I have a claim?
It's less. They claim less dense gases are holding down more dense gases.
Yeah,
it's really interesting.
Mm-hmm.
Who did that?
The heliocentric model says
no.
that.
Who? No. It doesn't say that. But first, let me ask you this: who in this room said any of what you just claimed that we said we claimed? All I asked was one question: have you done any of the math that you claim is supporting your idea?
Well, you know, your model. It's not you personally. It's your model. Your model requires that you, if you believe the model, you also agree with this.
Okay, so you're saying that as we get further out towards the moon and there's fewer and fewer molecules,
are you denying then that the gas molecules aren't
can I
there?
finish saying what I was saying before you talk over me? Is that a possibility? Thank you.
It's not preferred, but go ahead.
So when you guys were talking about the gases, from the Earth's atmosphere as they spread out further and further away from the planet, in other words, less gravitational forces keeping them here. And the thin molecules get in the range of the vicinity of the moon. Some of those gases are going to be pulled in towards the moon, but the moon's gravity is so weak that it's not going to be able to hold on to them. The molecules themselves, just based on their own movement, will escape the gravitational pull of the moon. So you'll find molecules all over the place in space. Space is not a complete vacuum. There's gas everywhere.
Literally what I just said, my friend.
Yeah, so what's the problem? How does that disprove the heliocentric model?
Well, the problem is this wasn't a position that was held by anyone not very long ago.
Oh, people change their minds. Is there a problem if new evidence comes out and they discover, what actually is going on?
Suggestion?
No, I'm trying to figure out what you're claiming. I don't understand what you're claiming because your
claim is that this community made these claims about exactly this nature, right? And then all of a sudden, the official story changes.
Yeah, and 100 years ago, people used to think that germs were, bad air.
Wait,
and then they changed their mind. Come on,
so
what's wrong with you?
Wait there, you're admitting you get your evidence from the flat Earth community then?
No, your flat Earth community didn't come up with that evidence. Flat Earth community had no idea anything at all about molecules in space. They don't even believe space exists. How in the world could you possibly? How in the world can you defend the flat Earth and then complain about? Hold on, I'm almost finished saying what I wanted to say. If it's okay with you, basically, how do you defend the flat Earth when you don't even believe in space? So you attack you basically say the flat Earth community discovered this idea of basically mass. As mass, increases, the further away you are from that mass, the less pull it's going to have on your, gas molecules, which is the reason why when you get up in space, you see a small amount of molecules that originally came from Earth still in orbit around Earth and still being affected by the gravitational pull of the Earth itself. Until you get farther and farther away, you eventually run into deep space where there's no pull from the solar system or anywhere else, in which case you'll still be finding gas molecules. But that's not a flat Earth discovery. That's just a simple fact of physics when you try to deal with why it is that gas molecules hang around large bodies.
I don't think he was. First of all, he wasn't saying it was a flat Earth discovery. He was joking with you. You missed it. But regardless,
Oh,
hey,
okay.
and real quick, I have to go. Hey, villain.
He slipped up and said it and made it sound that way.
Yeah, villain. I don't know if you've been here before already, but we put everything in the live stream one text as far as our memes and all that kind of thing goes. We don't use the side chat. Good to see you, by the way. It's been a long time.
Yeah, you too, brother.
But with the Woodsy, the discussion was real quick. Wait, real quick. I wanted to ask Woodsy real quick if you knew what we were talking about. And also within the globe model, do you think the globe model claims that the atmosphere all the way up to the Kármán line is in lockstep with the Earth, in perfect lockstep? Does the globe model claim that?
You mean the Earth's rotation or the Earth's movement?
The Earth's rotation. Okay.
As the molecules get further and further away from the Earth, and they don't have anything to collide against. In other words, as the atmosphere gets thinner, and if they are currently rotating in the same rotation as the Earth's rotation, there's nothing that's going to change their movement. In other words, gravitational pull on that one gas molecule will keep it close to the Earth up to a point. The problem is the fact that molecules themselves, they don't sit still. They're not just an object that just sits there. Like if you hold your hand out, you see it sitting still in front of your face. Until you go down to the microscopic and molecular level, you don't realize that your hand is moving all over the place. Well, any slight movement along that molecule will change its trajectory, and eventually it'll escape Earth's atmosphere if it's light enough. The heavier molecules, carbon, oxygen, nitrogen, and so forth, won't escape. They'll come back unless they have enough velocity to move away from the Earth's
Let me
pull.
stop you right there. We weren't talking about the escape of the atmosphere into space. We were talking about the atmosphere. Like, in your opinion, or as far as you know, do you think that the globe model claims, or do you agree with the idea that the atmosphere is in perfect lockstep with the surface below, all the way up to the Kármán line? Like it works like a solid, even though it's a gas.
No, it
and
works
there's
like a
fluid
liquid.
dynamics.
Okay, it works like
Okay,
a
so
liquid.
so
Gas-
fluid dynamics
gas-
would apply, right? So
In
according to
that
fluid
sense-
dynamics, it couldn't be in perfect lockstep,
Hold
right?
on. Not
According
entirely.
to fluid dynamics.
Because you're dealing with a gas, okay? And you have to understand, you're also dealing with the principles of gravity itself. As that gas is being pulled towards the Earth, there's also another force that's pulling it out away from the Earth due to the rotation. The centrifugal force is also pulling it out. So there's
isn't even
a
a claim.
combination of those two forces that are playing.
Uh-huh.
There's the gas molecule, the molecule itself. For instance, if it even goes through, let's say it discharges one electron for some reason, or has some kind of radioactive decay going on, at the point of its radioactive decay, that's going to cause some energy to be released. And when that energy gets released, it has to go somewhere, and that's going to trigger a movement of that molecule. Molecules do not sit still. They move around all the time.
Yeah, and they wouldn't move together as a solid body either, right?
No. They don't. But there's so many of them out there, and there's so much pull of the Earth's gravity. They stay in the general vicinity of the Earth. I don't know what you're trying to get at. You're trying to think that maybe these molecules will slow down and stop rotating with the Earth. Some of them will. Others won't.
No. Wait, you're misunderstanding it. If you don't know what we're trying to get at, the discussion is about the idea of the atmosphere moving like a solid body with the rotation of the Earth, so much so that a pilot could somehow be moved in that vector, in that eastward vector, tangentially, right? And be in perfect lockstep, so much so that he could just treat the Earth like it's stationary, even though he would be rotating backwards or sideways or whatever angle the atmosphere moves him with the Earth. So it would have to be in such perfect sync that he would just assume to treat the Earth like it's stationary, landing on it at another angle in the opposite direction, and then still moving 1,000 miles an hour backwards with the rotation somehow, with the quote unquote more or less lockstep atmosphere. Do you think that's how it works?
Okay, so you're talking about a pilot going against the grain of the rotation of the Earth, right? And he's going through an atmosphere that's following the rotation of the Earth, correct?
Yeah, with winds also pushing him in the opposite direction, possibly, or whatever
Depends on
direction.
the
Right?
wind.
Yeah, like
Yeah, it depends on
solar
the force of
wind,
wind.
protons, electrons, and heavy ions and stuff like that, right?
But everything, including him, is going in the same direction of rotation if he's on the ground. The minute he gets up in the air, he's still going in the same direction of rotation. He may be flying in the opposite direction and gaining, this is the reason why when you fly in the opposite direction of the Earth's rotation, you can outrun the sun basically. If you fly fast enough, you can outrun the sun's rising and never see the sunrise.
Forget about the sun for a minute. Wait, the first thing you said when you get off the Earth, right? Then you're, according to conservation of momentum, you're already moving at 1,000 miles an hour or 500 miles an hour, right? With the Earth. Is that what you're trying to say?
Yeah, and there's nothing out there that's going to slow you down.
Well, the friction of the air and the wind and all that, the
But
friction
it
would
won't. It
change
won't
that, right?
stop you. Yeah. Okay. But it won't stop you to a point where you slow down to such a point that you end up falling back to Earth because you have lift that keeps you going and
No, no
thrust
one's
that
saying,
keeps
no
you
one's worried
going.
about that because you have, yeah, the plane has lift and thrust.
So what are
You
you
can
trying to
fly against the
demonstrate?
spin. Well, if you're claiming that the reason that the plane, when it takes off, is in lockstep still with the Earth is because it was on the Earth because of the conservation of momentum.
It is,
Now,
but it's
it,
not. It's not consistent. There is a slight drag, and it will slow down
oh,
over
really?
time.
Okay.
But the problem is you can't stay up long enough for you to even feel it. It's such a small, minor change in your
It's not about
actual
feeling it.
what?
The
Movement
scenario is
requires
this. Listen,
feeling it requires some kind of acceleration or deceleration, and there's not
the,
enough. There's not enough in the
the,
atmosphere to slow you
I'm not talking
down.
about that.
But
You're missing my point. But
no, you're
you're
talking
missing
about
what I'm getting at. Let me
lockstep
show
and
you. Let
whether.
me tell you. Let me tell you what I'm getting at before you go off on
How about demonstrating it
bloviating.
mathematically so I have somewhere to go with this? Because right now
Yeah,
I
but
have
you don't
no idea
understand
what
what
you're
I'm
talking
talking
about.
about. So this question, I'm going to walk you through it, right? So if the plane goes up in the air at a certain latitude, maybe at a 500 mile per hour latitude, where it's said to be thought to be moving at 500 miles per hour eastward, tangentially, right? So then you can pretend or imagine or somehow that conserved momentum is making the plane go at 500 miles per hour eastward, even if it's going the opposite direction, right? Then you would just subtract the amount that it's going eastward and say that, even though it's going 600 miles per hour westward, we can say that it's also, subtracting the eastward amount. And then we can do the kinematics to somehow make it mathematically seem sound, right? But
No,
the
you're wrong.
problem is,
Go ahead.
okay,
I'll finish.
why am I wrong first?
No, go ahead and finish. I want to hear what the rest of you have to say about it.
Well, the scenario is that a pilot, right? Like there's two different claims. One is that because the object was on the Earth, whether it be a hot air balloon, whether it be a helicopter, or just somebody jumping up in the air, it's because you were on the Earth, moving with the Earth at 500 miles an hour, that you don't have the Earth spin out from underneath you, right? Isn't that the claim of the globe Earth?
Yeah, well, basically, it's
The
the claim.
conservation of momentum,
Sure, same thing. Or why when you jump up in a pickup truck that's moving, you land inside the
right?
bed of the pickup truck, and the atmosphere
Right.
isn't
Okay.
enough to slow you down.
Right. Now, you also know that pilots don't have to worry about the rotation of Earth. When they land, they just treat the Earth as perfectly stationary, right? You
No,
do
they
agree with
actually
that, right?
they adjust for rotation of the Earth in their plotting of landing and depending on the distance and how fast they're going, they have to adjust for that.
Well, what they do is they adjust for the 15 mile an hour degree
15,
rotation. You could think
15
of it as
degrees per hour
it's the
rotation,
Sagnac
not mile
effect,
an hour.
right? They adjust their gyroscopes or whatever it is. They calibrate, right, before they get in the air.
Exactly, which is a
But
side of
that's
rotation.
not actually accounting. It's not actually accounting for the rotation. It's just accounting for the drift
Where do you
that the
think the 15
mechanism
degree
is
where
picking
do you
up.
think the 15 degrees per hour
Well, that's a matter. Okay,
amount comes from?
regardless if you think that whether you agree that that's a matter of interpretation or not,
It's
doesn't
not
matter for what
interpretation,
I'm
it's
about to say.
math. It's the math telling you you have a
You can
body underneath
you're
you that's
interpreting that.
rotating. I'm
You're
going to finish
interpreting the
now, if
cause.
it's okay with you.
Well,
Um,
it's not what I'm trying to get
basically,
at. It's not my point, though. You're
well,
getting
then
off
get to
that.
your
That's
point,
just
because
a
I missed
side
it
note.
again.
Okay, yeah, I'm getting there, right? So if you're thinking that it's the conservation of momentum that allows the plane to land on the Earth as if it's stationary, because it can serve the momentum of the surface from being on the surface, right? Now the pilot is going to be flying to the equator, going in the opposite direction, west southwest, let's say, against the rotation the whole time. He doesn't have any kind of course correction because he's just a joyriding pilot, right? He's flying all over the place. He's flying in big loops. He might have even gone back to where he started because he thought he forgot something. Then he goes back and he doesn't have any destination. He's going to land in the clearing somewhere around the equator, right? And he doesn't have any destination, but he's going to land whenever he feels like it. He's got no internal system in the plane that's adjusting for anything. It's just a joyriding pilot and a Cessna. But he's going to be able to treat the Earth as perfectly stationary when he gets to the equator. Now that ground is moving at 1,000 miles an hour rather than 500 miles an hour. How is the plane automatically moving twice as fast eastward in that eastward vector, even though he only flew at 100 miles an hour average the whole time he flew there, right? How are you saying that the plane is going eastward now at 1,000 miles an hour in perfect sync with the ground, so much so that the pilot could treat that clearing as if it's stationary and not have to worry about the rotation being twice as fast as where he took off from?
He doesn't think about the stationary, the object being stationary. There's two things that a
He
pilot has
treats
to
it as
think.
like he treats it as such.
Okay,
That's a fact.
can I finish talking? The
He
pilot
does
thinks
treat it as
about.
stationary. Just want to make sure
I'm
you know
gonna.
that.
No, he doesn't. Okay, let me finish this.
He doesn't.
Finish what I have
Oh,
to
you mean
say.
he treats it as if it's moving? Okay, that's a
There
new one.
are two things that a pilot has to consider when he's dealing with the Earth's spin. One is the Coriolis effect if he's going north south, and the other one is the east versus west, or Estovas effect when he's going east or west. The problem with east and west is if he's moving with the Earth's rotation, this increases the angular velocity of him, and he has a slight centrifugal force that's pulling him away from the Earth at the same time, also acting on him, and it makes the plane feel slightly lighter, but it doesn't change whether or not he has to recalculate, based on where he's going to land, the new position of his landing site. It's going to move with him, so he knows the exact same distance. He's traveling the same distance, whether he's going with the rotation of the Earth or against the rotation. The difference is when he goes against the rotation of the Earth, flying west, he's going to be heavier. And because the centrifugal force is not as it decreases, so it's not as much, and so he's going to feel heavier and have to burn more fuel going against the rotation of the Earth in order to get to his destination. But again, the distance doesn't change because the place where he's flying to is rotating with the rotation of the Earth along with him, right along with it. So there's no change in
So you're
that.
saying the atmosphere is carrying the plane 500 miles per hour faster eastward in perfect sync with the ground so that the pilot doesn't have to worry about treating it like it's moving. He can just treat it like it's stationary
No,
because we think of him as in perfect sync
in the
because he's flying in
atmosphere,
the
traveling
air
at
and
he
the air is more or less treated like a rigid body, but it's just more or less in sync, but it's a fluid dynamic still, and it wouldn't really
no
be in sync, but it'd be
no
in sync enough to keep the plane in sync. What are you trying to say?
he's in sync. He's in sync with the atmosphere. It's moving along with
How?
him in the rotation, all at the same speed.
How? That's what I just said.
Can,
You
can I
believe that? You
finish?
believe that's possible?
Would you do me a
Okay.
favor, will you? I don't interrupt you in the middle of your statement and then say, and start
My
talking over you.
apologies. Please
Thank you. I
continue.
appreciate that. Okay. As he's flying eastward, the atmosphere is flying right. When he took off, the atmosphere, him and the Earth spinning, let's say he's at a latitude where he's at 500 miles an hour. Okay. So is the atmosphere, so is he, and so is the rotation of the Earth. His thrust, due to the fact that he's, flying through atmosphere, he's going to increase his speed as he goes along. That increased speed is added to his original speed that's based on an observer off the planet, not from the actual point where he took off from. The point where he took off from is also traveling at the same speed that he's traveling at. And so from that observer, it's whatever speed he's traveling through the air that they observe. But anybody off the planet of the Earth planet Earth will see him actually traveling faster than the rotation of the Earth as he accelerates through the atmosphere. Same goes, it'll see him going slightly less, slower than the rotation of the Earth, ever so slightly, as he goes in the opposite direction, flying west. There is no fluid dynamics involved in this because the atmosphere itself doesn't have a thrust or some mechanism, unless you're talking about the heat, convection, and winds and so forth, causing it to go faster than the rotation of the Earth. It's going to move right along with it. Any other forces that are applied to that atmosphere, such as a cold front going through, pushing air in front of it, causing it to rise as the cold front goes underneath, the cold air goes underneath and the hot air rises. That will change the speed of the molecules of the air who are traveling along with the rotation of the Earth ever so slightly in one direction or the other. Almost all of them go in the direction of rotation, except when you're in the southern hemisphere. Then you have it going in the opposite direction. So you've got all of this happening, and none of it is changing the fact that the atmosphere itself, in general, as a whole, follows the rotation of the Earth due to the gravitational force on the atmosphere.
And you said in general, as a whole, which is kind of like saying more or less, right? So you basically what I said, like you think the atmosphere is more or less moving along at the same speed as the rotation of the Earth.
There's a good reason for that, because in physics, when you have an object in motion, in order to change or accelerate its motion or to slow it down, you need to apply a force to it. The forces in the atmosphere are not enough to cause it to overcome the gravitational pull that keeps it on the Earth and rotating at the same speed as the Earth's rotation. Just like the plane itself would need to have a tremendous amount of force in order for it to go faster than the rotation, fast enough that it forever falls or goes in orbit, whether it's going against the grain or with it. In fact, I believe if you're going in the opposite direction of the Earth's rotation, you need to hit a higher speed of a higher rotational speed if you're out of the atmosphere, it doesn't matter. You still have to hit the same 17,000 miles an hour in order to hit orbital velocity.
Okay, but let's get back to my scenario that I was talking about. The joyriding pilot, right? He gets to the place in the clearing that he decides randomly to land in, and he does treat the Earth as stationary. Do you agree that he treats it as stationary?
Because as an
observer, do you agree with that?
As a local
I'm just asking
observer,
if you agree with that.
He has no choice. He's a local observer, so he's moving with the Earth, the Earth beneath him is moving with him. He's moving with it. The atmosphere is moving with it. So to him, it appears to be non-moving. Nothing is accelerating.
So you agree. I'm just trying to walk you through this. I'm not there yet. Walking through, we agree. The pilot treats it as perfectly stationary, right? He doesn't worry about the rotation whatsoever.
It's an illusion.
Let me get to my point. So then you also agree that the plane started out moving eastward tangentially with the Earth, had a conserved momentum of 500 miles an hour, right, when it started out. Now, even if you kept that idea that he's moving at 500 miles an hour eastward, even if he's flying in the opposite direction, but towards the equator, even if you still had that 500 miles per hour eastward conserved momentum, which would be ridiculous that somehow it's still moving eastward 500 miles an hour as it goes, 100 miles an hour in the opposite direction and then ends up at the equator, right? But even if you had all that 500, you need twice as much. It needs to be moving now eastward. Like say he's landing westward or west-southwest angle. Now you have to believe that the plane is moving eastward with the rotation of the Earth at 1,000 miles an hour, twice as fast as where he took off, even though he's slowing down to land in the opposite direction and never went faster than maybe 200 miles an hour the whole time. So you're saying you're not saying the pilot has anything to do with catching up with that extra 500. What's the mechanism that makes the plane go twice as fast backwards and sideways to be in perfect sync, so much so with the Earth that he can just assume it's stationary?
So you're basically saying that after he takes off, he flies past whatever airport he's going to land at, turns around, goes against the rotation of the Earth. The minute he does that, you're talking about a change in velocity that he's going to notice, so much so that he literally, the Earth's going to spin out from underneath him? Is that what you're trying to point out?
No, I'm saying he doesn't know anything, right? This all has to happen without the pilot even thinking about it. Because if he thought, wait a minute, I'm going 500 miles per hour faster backwards, he doesn't think about it that way. He just treats it as stationary. He flies point to point as if it's stationary.
He's not going 500 miles an hour faster backwards. If he's
You'd have to
making
be
a
if it's
turn,
1,000-mile-an-hour rotation.
no, he's equalizing the rotation. He's coming down for a landing, right? He's coming to a landing spot, right? The
But he's
landing
landing
spot
on a surface that's said to be
is,
moving 1,000 miles an hour at the
and
equator,
so is he.
compared to where
And so is he.
he took off. He took off from an area that was said to be moving at 500 miles per hour eastward.
So
Now
he
he's landing
gained
on a surface
500.
that's
So
a
he gained,
1,000 miles an hour.
right. You're missing basic math here.
That's twice as fast.
He gained 500 miles an hour going east, and he's losing 500 miles an hour going west. What number does that give you? 0, which means he's back to moving at 1,000 miles an hour in the same direction as the Earth. Which means as he comes
No,
in for
what
a
you just did
landing,
there doesn't
he
make any sense.
negates. No, what I did was I just basically did basic math. If he's taken off and he gains 500 miles an hour as he's flying in the direction of the Earth's rotation, the minute he goes in the opposite direction, he negates that 500 mile an hour gain that he has, and he's now traveling at the same speed as the Earth is, and has to gain another 500 miles an hour in order to land. But he doesn't
But
have
he doesn't
to
worry about
because
any
the
of
Earth
that.
is moving towards
Wait,
him.
first of all, he just treats it as stationary. He doesn't have to worry about that.
Exactly, because he's a local observer. You keep thinking that this has something to do with the way with the physics. It's everything to do with the observer. Because when you're watching from out in
the
space,
surface of the
you're
Earth.
going to see
Can I
a
try and
zero
clarify
change.
this?
Has nothing to do with the outside observer. That's a side issue. That's not even a side issue. That's just a way of you can look at it like an observer outside. Listen, the ground is said to be moving 500 miles per hour faster, according to the globe model. The conserved momentum is what you said to begin with, keeps him in sync. But the pilot doesn't ever move the plane to be in sync with the Earth. You just have to assume that the atmosphere somehow is a rigid body that moves the plane backwards at just the right amount, so he can always treat the Earth as stationary, even though that physics wouldn't allow that. He can't fly the plane backwards. The vector forwards. Listen, the vector forwards has nothing to do with that eastward vector. That eastward vector that has to be twice as fast, no matter what angle he's landing at, has to be carrying him backwards 500 at 1,000 miles an hour, which is 500 miles per hour faster.
No, that's where you're wrong. He has the same frame of reference.
Can I say something real quick?
Yes, quickly.
Yeah. So if I've understood the issue, I think what he's looking for is the air itself is moving at different speeds at different latitudes, right? Like when we say in aggregate that the atmosphere is in lockstep, at the equator the ground is moving 1,000 miles an hour. Higher up it's 500 miles or wherever you set that at. The air above that ground is doing the same thing. So as the airplane is pushing,
as if it's a rigid body,
which is what it uses for.
Okay.
No, you don't have to go as far as that.
All the air molecules have only one.
It would have to be a rigid body is the point we started with. This whole conversation started with, you could have a steel rod that's connected to the ground, and that steel rod could go all the way up to the Kármán line, and you could think of it, even though it would sway. But you can't treat molecules of air as if they're a steel rod moving a plane somehow tangentially as a gradient, keeping the plane moving backwards faster as he's flying forwards at 100 miles an hour only, and then landing and slowing down to land. And somehow you have to imagine he's moving with the Earth. You just have to imagine it and then say it's the atmosphere, even though the atmosphere wouldn't work that way. And you agree it's a fluid, which fluid dynamics wouldn't allow. And it's gas, which is even worse.
Right now,
but now you have to come up with something that's not just about an outside atmosphere.
I think you just need to let it run out of batteries.
Go ahead.
Are you done now? Thank you. All right. So you're forgetting one small problem. He has a frame of reference of where he's at. That frame of reference tells him that he's moving along with the Earth's rotation as he takes off from the plane, whether he's going in the direction of the rotation or against the direction of rotation. From his frame of reference, everything is going to be stationary because he's moving.
Because it's stationary. That's why.
Okay. No. Again, if you'll let me finish and not interrupt, from his frame of reference, everything has the appearance of being stationary. But
I wonder why.
Let me finish. If he's on a rotating sphere And by the way, the Earth, when it moves at 1,000 miles an hour at the earthquake, at the equator, is not going to have any visible movement for the naked eye from any point where you're at, even when you're out in space looking back at it, because it's moving so slowly at 15 degrees per hour. It's almost like being on a merry-go-round that's moving at 15 degrees per hour, and you're sitting on the edge of that merry-go-round. You're not going to feel it moving at all. You're literally going to be sitting there like
merry-go-round.
it's a
It's
point
that
that I'm
merry-go-round
getting at.
well, if the merry-go-round were as large as the circumference of the Earth, then
Right.
you'd be moving at 1,000 miles an hour
And you
in that
wouldn't feel it.
merry-go-round, and you
And
would
you
definitely
wouldn't.
feel that.
No, you wouldn't.
You wouldn't
because
feel 1,000 mile an hour
and the
merry-go-round.
again, you're missing one point. Okay, the atmosphere that's above the merry-go-round and everything else is rotating with the rotation of that merry-go-round.
As if it's a rigid body, which is the point you came in on.
That's
As if it's a rigid body, which it isn't, is the point.
oh
Yeah,
god.
your whole argument hinges on
Oh
the
God,
fact
this guy's here.
that you
I'm going
have
to leave because he's here, and I don't
Yeah,
particularly get a chance
Yeah,
to argue very well when he just constantly talks over me. So
because your whole argument
Lion's good
hinges
for
on
that.
That's because your whole shit's hanging in the
I
balance, son.
can't even, it's irony because I can't finish my sentence. Your whole argument hinges on one fact,
Because
right?
nobody wants to hear you talk, Lion. You talk too much.
Yo, who's that right there, yo? Who's that?
well, it's not me, but I'll agree with him.
Yeah, so your whole
I think it's Mateo fucking with you. I don't know. Go ahead, Line. Go ahead, Line. I want to hear what Line has to say.
Can I get it out, dude, please? Right, so their whole argument hinges on the lockstep atmosphere. That's what makes all of this possible. Yet, how is that possible on a sphere that's spinning, right? How do you preserve the energy all the way to the Kármán line? That was the original dilemma. You still haven't overcome that. All this is digressing from the original point. How do you have a whole atmos, a whole system that's basically fixed and in lockstep as if it were rigid with the surface of the
with all the variables of wind going in all directions and planes flying in different directions at any kind of variable speed? What about a jet that goes 1,000 miles an hour, in the opposite direction? And you have to believe that it's also being pushed backwards at the same rate as the Earth, and like somehow that force is still pliable. It's just ridiculous, you guys. It's over.
So
It's just
can you guys
just
give
physics,
me
man.
the ad hoc reasoning, the ad hoc rationale, right, for how your atmos is in lockstep, predominantly in lockstep?
Way to poison the well. So this goes back to the question I wanted to ask earlier, because somebody mentioned how there was a story some time ago, and then we updated the story to sort of retcon the whole model. Can you tell me what do you see as the difference between an explanation and an excuse?
Well, what's the difference between a kinematic solution and one that actually includes dynamics? That's what we're talking about, dude.
We're just gonna keep asking questions back.
Shall I
asked
repeat the
question,
question?
and he asked the question, and you asked the question.
Yes. And your question is, what is your ad hoc rationale for this? So given that you're trying to very blatantly poison the well, I want to get this out of the way. I'm asking, and I'll ask again, how do you see the difference between an excuse and an explanation?
An explanation isn't always a defense. An excuse is.
No,
they can be the same thing. You can have an explanation that's
what
just
it boils
an excuse. You can have an explanation that's just an excuse. Kinematics. If you have a mathematical kinematic solution, you can just give the kinematics as if the math proves it's true, because you could subtract 500 from 1,000 and just say, oh, the atmosphere allowed the plane to be going 1,000 miles an hour, and somehow we think of it that way kinematically. So we're just going to pretend the dynamics are there and they work too. That's the difference.
No, but I just want you guys to know. I want you guys.
Sorry, can I say something?
Right,
I was in the middle of trying to say something. In response to what you said earlier, it sounds like the suggestion there then is that if I ask you something in a sufficient accusatory way, anything you tell me as an explanation, I can just take as an excuse. Do you understand the problem there?
Can we stop digressing? Can you answer the question, dude?
Yeah,
What
totally
makes the
digressing.
You jumped in
Total
and I was in
digression.
the well because you
How?
want to change the subject. And you won't
Oh,
even let
dude.
me finish my explanation. I just find that incredibly fascinating. This is what you want to do. You want to sit there and you didn't get. I tried to give an explanation of what the Stovus effect is, and you didn't want to hear it. Now I'm sitting here
Oh, well,
having
no,
to listen
I'd
to
love to
you.
hear that. I've never heard of that. What's the osmosis effect? Go ahead and explain that. Osmosis.
It's Utvish. Utvish is actually the pronunciation for it. That is
Goldfish
basic.
effect.
Yes, that's the mathematical equation that explains what's going on with the rotation of the Earth, the effect of any object that is traveling either with the rotation or against the rotation. That object obviously requires to have force applied to it in order for it to successfully do that. An airplane has that. It's called thrust from its engines, and it allows it to do so. And so this formula basically tells you what's involved in from the observer's point of view that's local. In other words, the person in the plane who's flying the plane, why it appears to him that he's flying over a stationary surface, but it's not.
Well, you said oudfish. How do you spell it? OUD fish.
No,
He's talking about a very slight multiplied force because of the centrifugal force of the Earth itself. It's being
But
transferred
I
to
want
the
to look it
object
up.
no,
I want
that's
to
not
make
what I'm
sure before
talking
I get my
about.
point in. I want to know what you're talking
the
about.
law of
How do I
conservation
spell
of
it?
momentum.
It's in
Like
chat. You'll find it in chat. I put
it's like
up an image of the actual equation.
it's like when
Okay,
you
now
shoot a bullet.
now this is what I was saying about the kinematics versus the dynamics. That whatever that equation is, right? You could just put that on the paper and then think of it as in sync. But the dynamics have to actually be there as well, which is you're treating the atmosphere like a rigid body. Now, you just mentioned that the plane has thrusters as if the pilot's doing something to make the plane go 500 miles per hour faster eastward. You don't think the pilot's doing anything, do you?
He said that.
You
Nobody
think
said
the
As I
that.
pilot has
explained,
something to do
as
with
I
the plane
explained
moving
earlier, the
This is all
only
faster to
irrelevant.
thing,
be in
This is
sync with
all
the faster
irrelevant,
surface?
bro. Bro, don't
the
let, dude. You're getting away from the
oh
original
fuck, he
question,
won't
dude.
shut up, so I'm leaving. Have a
You have
nice time, guys.
bro. You don't let me talk. I was talking earlier and you
Because
interrupted me.
we were in the middle of
You
a
don't let me
conversation and you
explain.
walked in and
You don't let
spoiled
me
it.
explain,
So go fuck yourself.
bro.
See you later,
Listen,
guys.
you have to explain what makes the atmosphere in lockstep with the surface of the Earth. Then we can get on to this other shit. All this other shit is redundant when you
Sure.
can't even explain
I'll do
what
that
makes
for you.
the
Okay.
atmosphere. Okay, go ahead.
But that was my original point.
Okay,
Was that
so
we have a differentiation in the atmosphere that's in lockstep with the moon, which is way, way closer than the Kármán line, right? So it's like, again, extrapolate what
this
goes
guy.
on the moon. Extrapolate it.
No,
And then see if it applies.
let's not
right?
complicate it because it's already complicated. So
Yeah,
the
we
short
should
answer
we
is
should look at
it's
the
complicated.
equations
But
I posted after
basically,
you asked them, right?
so basically, what it boils down to is conservation of momentum, right? Like, however the atmosphere got here, and we're not rightly sure. It could have been comets with water that evaporated, or chemical reactions under the surface, or whatever was produced on the Earth. However it got here, it inherited the momentum of the Earth, right? For it to change, somebody kept mentioning like losing energy. Like, I don't know what that would look like exactly, but someone's talking about wind in all direction. That's just going to cancel out, right? So fluid dynamics isn't a matter of one direction or another direction. That in aggregate is going to be pretty much the same, right? That's going to all equal out
On
to
paper,
whatever the
kinematically, you can
atmosphere
do
is
that and
Hold
doing.
on, dude.
cancel
I
it
got
out.
next, bro. I got next, dude. I'm waiting for him to finish.
Sure, and I can address the kinematic dynamic thing later, but the basic thing is when we say that it's in lockstep, that's not the same as saying it's a rigid body, right? Those are not the same thing. Fluid dynamics, turbulence, like then it gets even more complicated if you want to talk about like jet streams and trade winds, but basic grunt of it is that it inherited the momentum of wherever it was in the first place, and that's basically how it's going to keep going unless something stops it. And because there's no friction on the outer edge of this atmosphere, nothing's going to stop it. It's just going to keep doing what it's doing. That's a very
All right, dude.
simplified version, but that's basically what
Yeah.
you're looking for.
So Almost. You didn't really get to the nitty gritty though, right? I'm asking you, what makes it possible? What you said that the Atmos inherited the energy, right, from the Earth due to the law of conservation of momentum,
Yes.
right? But you don't seem to
Yes.
understand how fluid dynamics works, because the pilots, they treat the Earth as if it's fixed and stationary, right? The atmosphere
Yes.
it's as if it's not moving at all, right? It's as if the Earth is not moving at all, because it's reached an equilibrium, right? That's what I'm asking you.
Stop saying equilibrium.
How
That has so many extra things you're bringing into the conversation that don't matter. What I'm saying is that the atmosphere compared to the Earth has minor fluctuations within it, right? That's the fluid dynamics. And those the pilot just treats as wind, right? You have wind that the pilot has to take into consideration.
Dude,
It shifts him left or right or back and forth.
Stop. Hold on. Chill out, dude. You're deflecting, bro. Fuck the dynamic winds, dude. Fuck the jet streams. That's all logically irrelevant to the topic. Granted, yes, there's jet streams. Yes, there's low pressure and high pressure systems. Yes, there's wind, dude. Right? That's not the problem, dude. That's not the focus of the topic.
Okay, so what's the problem then?
That's all within a system that's in lockstep with the Earth, right? All the dynamic winds, that's within an overall system that's predominantly in lockstep with the surface of the Earth. It's reached an equilibrium. So granted, yes, you have dynamic winds within a system that's reached equilibrium to the point where at the Kármán line, it matches a tangential velocity with the surface of the Earth. That's your model, dude. I'm asking you, what made that possible?
So when you say it reached equilibrium, you're suggesting that there was a time where it was in disequilibrium. That was never the case. As soon as that air was on the Earth, however it got there, it inherited that momentum. There was never a moment where it had to equalize or become one thing. It always was.
That's not. So you're just affirming the concept. You're just gonna dogmatically claim it always
not affirming the concept. I don't know what you mean by dogmatically claim, but that's
even
what
if
the
it was
physics
predominantly, I have to go. But even if it was predominantly, that's not good enough. You can't. There is fluid dynamics. It is a gas. You're treating it as if the whole thing, the atmosphere with all the variable winds going in every direction, as if that's still a solid body that we can just pretend is in perfect lockstep with the rotation. But the problem is there's a plane that's detached and said to be in sync because it was on the Earth, not because it's in the air. The conservation of momentum is because the plane was on the Earth. So you're saying the air moves the plane when it comes, like you're saying that the wind, when you jump up in the air, that it's not because you were on the Earth that you're in sync with the Earth. It's because the air pushed you with the Earth.
The fact that the plane took off from the ground is why it has its initial momentum. When it's in the air, it's pushing off of the air, right? So the air, if it's going 1,000 miles an hour at the equator, it's going 500 miles an hour somewhere up there. There's a differentiation there that as you go north or south or wherever you're going to push off of that air in a way where you're going to feel some minor side winds, right? But that's going to be effectively lost.
Wait,
in the hours that you're traveling from 1,000 to 500.
But manufacture, you have to manufacture totem, whatever. Chucky, yeah, you have to pretend, right, or believe that even though the plane went in the opposite direction from the place where he had to conserve momentum from being on the ground, right? So the air is not pushing him when he gets up in the air. It's the initial conservation. Then that goes away because he's going the opposite direction for 8 hours till he gets. He's got no ground path he's correcting for, so the winds don't matter. That's another variable, right, that goes along with it. That would be adding to the friction that would take away from the conserved momentum. But then you have to believe that the air as a whole is constantly moving him backwards to be in sync with the faster rotating Earth, even though winds could be pushing him in all directions the whole time. And then you have to believe as he's slowing down to land in a clearing that he finds somewhere along the way at the equator and he treats the Earth as stationary, you have to believe that the air is carrying him backwards 500 miles per hour faster at 1,000 miles an hour in perfect sync with the Earth as he's slowing down to land in the other direction. That's what you have to believe.
You have to believe that the
Do you believe
atmosphere is
that?
in lockstep to make all that.
And it's not even in lockstep.
Yes.
Right. And the dynamics, because it is fluid dynamics,
No,
and
it
it's
is in
not
lockstep.
more or less in lockstep's not good enough. More or less wouldn't even be good enough, even if that were somehow possible.
More or less is just minor fluctuations. That's the point.
Hang on, you also have to believe the original air that you say got to the Earth, however it got here, right, was on the Earth. Then it, through conservation of motion, was put into the air, and that's the thing that then maintains the conservation of motion of the plane, that it gathered from the ground, then was put up into the air, and that's what creates the conservation of motion. So what was it that the air itself that was first here was pushing off of to create that?
Yeah, what's the mechanism, Chucky, that makes the plane be carried backwards at 1,000 miles an hour without the pilot knowing anything about going 500 miles per hour faster eastward? And that eastward vector has to remain separate from his forward motion, so it has nothing to do with the thrust of the engines, like Angelo was trying to imply at the end there. Like, it has nothing to do with what the pilot does. The pilot just flies point to point as if it's stationary, treats it as if it's stationary, and then you have to believe somehow this eastward vector is somehow kept consistent. The atmosphere itself is not said to be in perfect lockstep, so it wouldn't even be good enough, even if it could magically make that happen. Because if you were landing with crosswinds, if you were landing a plane with crosswinds and a rotation of the Earth that isn't in perfect sync with your eastward vector backwards as you're landing facing westward, so you'd have to, if there was any slight variable of the Earth moving at a different rate than the plane is moving backwards, it has to be a perfect 1,000 miles an hour backwards as he's slowing down to like 50 miles an hour to land on a stationary Earth, something he treats as perfectly stationary, and then somehow the plane's still being moved at a lower altitude. As he goes down, the air is still pushing him backwards at 1,000 miles an hour. That is ludicrous. Do you get my point?
I don't even know what you said.
It's too much. It's too much to absorb. Yeah.
Like you're trying to make it sound like
if the air is keeping the plane in sync, and the air is more or less with the atmosphere, you'd have to believe the air is pushing the plane at a faster rate to be in sync with the 1,000 mile an hour runway or clearing or wherever he's landing. It's moving faster than where he took off from.
Yeah,
it doesn't work.
Yeah. They have to believe that the atmosphere is in lockstep. Because
the air is pushing him backwards at 1,000 miles an hour as he's landing down to zero in the opposite direction. You have to believe that, even though there's no mechanism and no dynamics to even show that, to even make that seem possible to any common sense person.
There's no proof of concept.
Maybe I don't understand what it is you're suggesting exactly. What do you mean by pushing him backwards 1,000 miles an hour?
Well, if it's the only reason the plane's in sync with the faster rotation is because he's in the air, right? That's said to be moving with the Earth, right? So you have winds in all directions. Right. So he could be dealing with crosswinds, westward crosswinds as he's landing, right? But if the Earth were moving eastward, different. No. I'm talking about the actual surface of the Earth would be going at 1,000 miles an hour now, where he has to be going in that eastward vector at exactly the same. The plane has to be moving in the eastward vector exactly the same rate for him to treat it as stationary. Exactly. So you have to believe the air is making him go backwards at that rate. The air is pushing him backwards at that rate.
The air is moving at the same speed as the surface, roughly.
Yeah, but more or less. You're saying more or less. It can't be perfect.
Yes, wind, because we have wind.
Yeah,
but planes fly in wind. They account for wind.
Yeah. Winds. Dealing with winds as you're landing, as well as a surface that's moving eastward at a different rate.
No.
Would be two things to deal with.
Not as well as.
No, it would be both things. It would be both things. It would be two things. You got westward air. Listen, you got westward winds, and you got an eastward rotation. That's two things to deal with.
Into that phenomenon.
It's not the same. You cannot conflate. You can't conflate wind with rotation. That's how you justify it. You're conflating winds with rotation.
Dave, you're
There's a difference
I'm
in
not
rotation
conflating
and
anything. What I'm
winds.
saying is
That's
that's
two
what it
things.
means when I say the atmosphere in aggregate is moving in lockstep with the Earth. But the minor fluctuations we perceive as wind. That's all that is. It's
the
No,
not
no,
that
dynamic
no.
wind.
complicated.
That's the
Forget
conflation.
about.
That's the contortion. That's the mind
What are you
contortion you
talking
have to
about,
do
Dave, dude?
to make it work, right? Because the
Dave,
winds
Dave, you're
moving in
just
all directions
complicating
is
it, dude.
different than the
It doesn't
rotation. Hold
have
on,
to
Lion,
be
real
that
quick.
complicated.
Lion,
No,
hey,
dude,
Lion,
not
I'll
real
let you
quick, dude.
take
You're
over.
hogging the mic,
Hey,
dude.
Lion, I
You're
have to
hogging
leave,
the mic.
so
Nah,
I'll
fuck
say my
that.
one thing.
Yeah, leave, dude. You're hogging the fucking mic for 30 minutes, dude.
Yeah, but
Trying to
you're
get
on here
in.
all the time for hours. Dude. Just let me say this, and I like what you're
Oh,
saying.
good.
I don't think we're disagreeing. Just
Dude,
let
you're
me
not.
say
The
this
thing is,
before I
dude,
go.
you're losing the audience in obscurities, dude. Just repeating
No, I'm
yourself
not.
100 times isn't helping anybody. Yes, you
Well, if
are,
I
dude.
can't say, well, dude, if you're lost in obscurities, let me say my thing to clarify real quick before I go, because you're not understanding it then.
Lost me a
If
couple
there's
times.
winds moving in all directions, right, and the atmosphere is said to
Hmm.
be in aggregate or more or less or predominantly or whatever estimation word you want to use, the estimation isn't
Sure.
good enough already. So the atmosphere
That's
as a
plenty
whole
good.
moving in more or less perfect lockstep isn't good enough, even if it were pushing the plane backwards. So you have to believe that the air is moving the plane faster backwards as it goes towards the equator, so much so that the pilot can treat the Earth as perfectly stationary, even though we got winds in all directions and a rotation that's not in perfect sync because it's not even said to be. It's more or less in sync. So you would have a variable. You'd have to train the pilots as if they're aircraft pilots, aircraft carrier pilots, where they're dealing with a slight drift of the surface moving in one direction, as well as winds possibly moving him in all directions. That's two things to deal with. The ballers always try to
No, see what I'm
conflate
saying.
winds with rotation and say the winds are the same thing. The winds would make the Coriolis be lost in the winds, hidden in the winds, right? So that's why we can't worry about Coriolis because it would be strong, and that's true. The winds would be
Yo,
more of a
come,
thing to deal with.
Dave, yo, somebody, please, listen. Yo, come on, man.
Okay,
That's
let me
maybe
briefly
I
Lion.
lost
address
you
what he
again,
said
but I'm
to
saying
you.
that two things to deal with
I
is
think we
not the
got it.
same. You're saying winds are the same thing as the rotation, and they're not.
Yes.
The rotation wouldn't be in sync. The plane would
He
not
didn't
be
say
pushed
that. He
backwards
didn't even say
to be in
that, dude.
sync.
He didn't even
He's
say
saying
that.
the winds. He's saying the air moves the plane in sync with the Earth, like a rigid body. That's what he's saying.
Not
Yeah.
like a rigid body. No, not like a rigid body. But I am
Okay,
saying
then
that
like what?
when the atmosphere is moving different from the rotation, that's just wind. That's what that is. It's
Yo,
not
let me
two
get.
You got
different
winds
things.
going in
Yo,
all
let me just
directions,
say this
dude.
one thing, bro. I'll be quick. I'll be in and
Yes.
out, dude. Yo,
I'm done. I'm
Go
done.
ahead.
I'm
yes,
saying if it
you
was the
treat.
wind, if the difference was the winds, it would all be the same wind because it would be based on
I'm
the
done or not?
rotation. It wouldn't be winds in all
Yeah,
directions.
you're
Sorry,
done. Yo,
sorry.
listen, dude. They treat the Earth right as if it's in lockstep, with the exception of dynamic wind, dude. And I don't. He
Yes.
keeps running to dynamic wind, dude. We know, dude. We
I'm
know
not
that
running
there's
from it.
jet stream. Yes, you are. You keep using that, bro. Like you're strawmanning our position. So, with the
Right.
exception of dynamic wind, you have to
Hmm.
treat the Earth and its atmos as if it's in lockstep, as if it's
Yes.
completely in equilibrium with the surface of the Earth.
I don't like that term equilibrium. I think that that has suggestions that I wouldn't agree with.
Why? Because there's dynamic wind. I already told you, with the
No,
exception
no,
of dynamic
I
wind.
understand that. What do you mean by equilibrium?
Synchronized. That the surface of the Earth's atmos, right? Couple inches above
Synchronized
the crust and the Kármán line, all that mass of air is synchronized.
to the
Okay,
rotation of
just
the
say
Earth.
synchronized. Just as a personal favor for this conversation. I can agree with synchronized.
1-for-1 in perfect lockstep.
Yes.
So you have to treat the Earth, the whole system overall, predominantly, right?
Don't say rigid body.
It's synchronized or equilibrium,
Yes.
as if it were a rigid body, with
Nope.
the
Not as if
exception
it
of
were a rigid
dynamic
body.
wind. With the exception of dynamic wind.
Yes, but not as though it were a rigid body.
It's basically, dude, come on. Without the nominal fluctuations, it's basically as if it were a rigid body, which is you can't explain that. Those dynamic forces, you don't even have a proof of concept that such a thing is
The
possible.
Earth rotates east to west. So the problem that you're going to have here, right, is regardless of the dynamic wind, you're going to have what you call an overture in like basic pressure in the actual air, considering that you do admit that there is this air itself that's in lockstep with conservation of motion, right, that's synchronized in this direction. So, like, you would utilize that, and there would be evidence of people utilizing this exact thing. Go ahead.
Yeah, the fact that airplanes can take off from one spot and land in another with no problems. That's exactly what that means. That's why that happens.
From the consequence. But yo, listen, think about putting a ball, right? Putting a massive object inside of a container, right? Or a vacuum, right? Put a ball inside of a vacuum, start spinning it, and then start adding gaseous substances, water vapor, whatever the case may be, right? And then that gas then has to start spinning with the rotational velocity of the ball. That's what your model suggests, promotes, that the
Not
Atmos,
exactly.
right, is spinning at the exact rate, right, of the crust. How is that possible?
So your metaphor is a little problematic in that I imagine we're doing this on Earth, right? And as you inject this vacuum container with whatever air or liquid, that's going to be the predominant force, right? Otherwise, if you had this in like the vomit rocket, for example, or out in space or whatever, you would need that ball to have some sort of attractive force. You could make it magnetic, I suppose. But whatever you do, you would have to not just inject it into the air around the spinning ball, but either have it come from the ball or have it sort of meet the ball in a way that it inherits that momentum. That's the mechanism. And I don't think you have that in your example.
No, yeah, we
Hey,
can't.
hey,
There's no way
hey,
of
Lion,
actually
Lion.
providing a model. Yeah, go ahead.
Hey, Lion, real quick. I still have to go, but then talk about the jet streams, right? To say the jet streams are moving up to 200, 400 miles an hour faster than the supposed rotation, right? So that
Yep.
plane gets in the jet stream. Now it's moving faster than the rotation. Then it jumps out of the jet stream and then still somehow just treats the Earth as stationary. How's that work?
The same way.
The
That's
jet
what I
stream
meant when
doesn't
I said
have
The
it's
that.
same way?
complicated.
In what
Because
same way?
there's
So the
things
air
like
slows
super
it down then
rotation at
after it gets
higher
out of the jet stream?
altitudes.
It gets canceled
Back
out.
in the middle of a sentence.
The momentum of the Earth, right? All that stuff. When it comes to the jet streams, bro, it's canceled out.
Yeah, Lion gets it.
Yeah, mathematically, you can just kinematically cancel it all out and treat it as if it's stationary, even though it's not. That's the kinematics versus the dynamic.
Yeah. They had to treat it as if it.
How do you
Yeah.
just
But this is what I'm
so
asking you, bro.
similar
Like,
to my question earlier? How do you distinguish between kinematics and dynamics? Like if kinematically they're both equivalent, how do you determine which version is correct?
dynamics, you have to provide the forces at play. Kinematics is just simply observation that are equivalent in both models.
Yeah, you can mathematically make it seem like it works, even if it wouldn't work dynamically.
What if the mechanism works in both systems, in both models? How would you determine which one is
Well,
actually
there's
dynamic?
no dynamics. You don't have an
You know,
air pushing the plane backwards. You don't have any dynamics to that. That's just the kinematic concept that the model says that's so. That's not doesn't make it real. That just makes an excuse, like you were asking about earlier. That's an excuse that you think is an explanation.
It would,
but
yeah, but even kinematically, that would still be an explanation. Like even dynamically, that would still work, though.
think about spiral galaxies, man. And I'm just thinking of something that I could use as like an example besides a blender. Think about spiral galaxies, right? Now you have the nucleus of the galaxy, and then you have the outer arm. Now there's it's called differential rotation, right, between the outer arms and the nucleus of the galaxy. In your model, you have to say that the Earth, the sphere, right, that the gases that are at the outer edge, right, of the Atmos near the Kármán line and beyond, even if it's very minute, that those gases are now equal. There's no differential rotation. They're equalized. They're in equilibrium with the surface gas
Oh,
in their rotation. So it's like if you were to look out into the galaxy, right, or into the universe, and you would see these galaxies, that the outer arms will be spinning at the same tangential velocity as the nucleus of the galaxy, which we do not see. There's differential rotation even out
yeah.
there.
Yes. That's different. It's a different mechanism out there than on the Earth.
What, you're dealing with gravity? What's the difference?
Yeah. That momentum was not inherited in the same way. Right? Some of these things come into the orbit of the galaxy, right? The nucleus of the galaxy, but they never like shoot out from the center of that galaxy. That would
These
be a
atmospheres be
different.
like Medici bloodlines.
Yeah. Okay. I mean, I get your point. I would say that's a different mechanism. So
But the same
like
thing with fluid dynamics. You're going to have a lag. There's going to be differential rotation, especially when you consider the circumference. Where is the dynamic forces coming from? That's why he keeps mentioning kinematics versus dynamics. You might have a
Yeah,
kinematic
he's talking about something
explanation,
different, I think, than you're
but
talking
how
about.
do you explain it dynamically? Where is this added energy coming?
You have no mechanism. You just have a kinematic concept.
No. So there's two different things being spoken of here. I think he's talking about how a plane gains momentum as it goes through the atmosphere if the atmosphere is, in lockstep. You're talking about how the atmosphere is in lockstep in the first place. Have I got that right?
Yeah, you can explain it kinematically, right? But how do you explain it dynamically?
Well, the atmosphere being in lockstep with the Earth, I don't think that is a matter of kinematic or dynamic. That just
Oh, it absolutely is.
That's just a concept that I accept. It has nothing to do with kinematics or dynamics. Is that what you're saying?
no. It's just no. That's not what I'm saying. I'm saying that there's no I don't know what that. I mean, the explanation, as best I can say it, is it inherited the momentum. I don't know what more you have an issue with there. Are you saying it didn't, it couldn't have, or are you saying that there's something else that would influence the system?
It's not even. That's not even the way that they. Okay, let me ask you this: if the plane goes into a jet stream going 200 miles per hour faster than the rotation, did the plane inherit that momentum?
It's getting a 200-mile-an-hour push to some degree, yeah.
So you're saying
That's why
that
it goes faster with
when it comes out
tailwinds.
of the jet stream, then it has to go. Then it has to slow down to be in sync with the Earth again.
Well, no, if there's a difference between the jet stream that it was traveling in and the air that it's now entering in, then it's going to feel that difference, right? I don't know if you've ever jumped out of an airplane before, but the moment you jump out, it feels like you're being pushed by that air, as opposed to,
Sure.
for example, jumping out of a hot air balloon, where the air you're in and the air that you jump into is relatively the same speed.
Yeah, and that
So
air,
there's two
when you
different
jump
speeds.
out, that air could be pushing you the opposite direction of the rotation, right?
Right. So there's
Yeah.
an interesting experiment that was done with driving a car. It was on MythBusters, right? They wanted to recreate this movie scene where there's a truck with an open truck, right? It's got the tail dragging on the asphalt, and you drive into the thing, right?
Yeah, 80 kilometers an hour. Eject him out the back. Yeah, he lands on his feet and he's like standing up.
No. You're driving a car onto a truck, onto a moving truck, right? And the prediction, I think it was Adam's prediction, was that the wheels would grip on on the bed of the truck and immediately shoot into the driver, right? But what happened was the momentum of the car made it such that the wheels slipped a little, and it didn't have enough energy to like bolt the car forward, but it just drove into the truck pretty smoothly, right? So you have several different things in this airplane jet stream scenario. You have the jet stream carrying the plane, and then you have the plane go out of the jet stream into presumably a slower air, right? You're going to have the momentum that it's traveling at, the mass of the airplane. There's all of those things are going to play into. It's not just going to go the speed of the slower air, but it's also not going to be the same speed as the jet stream, right? There's a mitigation there that happens. I don't know if that made sense.
Well, yeah, there'd be so many variables that he would have to be doing something on the pilot's part to make sure that he's in perfect sync with the ground that he's about to treat as perfectly stationary. But it doesn't happen. Somehow that all works itself out so that it's in
Yes.
such perfect lockstep that it's just going to treat the Earth as stationary no matter what the pilot does.
Yes.
Somehow that eastward
he's just
vector,
gonna.
that's the concept. That's the kinematic concept that has no dynamics, and any kind of explanation you try to work into a dynamic, force that makes that happen, you're going to sound more and more ridiculous as you try to justify it. The only thing you can say is it's equal. I don't know how it works, but all these variables cancel each other out so that it's just like it's stationary, even though it's moving at 500 miles per hour faster, or the plane has to be being pushed backwards at 1,000 miles an hour to treat the Earth as stationary.
I don't know what you mean by push backwards, but yes, if it took off at where the Earth is rotating 500 miles an hour and it's landing where it's moving 1,000 miles an hour, it will have inherited that speed as it's pushing off the air that's also moving at those two different speeds in those locations, right? So the air is moving at 500 miles where it took off. The air is moving.
He tried to convince a pilot that his plane is moving eastward at 1,000 miles an hour, which is 500 miles per hour faster, possibly. Or if he took off from the pole, it'd be 1,000 miles. If you try to say that mechanically, dynamically, his plane is now going 1,000 miles an hour eastward, and consistently so, even though he's aimed the other direction and slowing down to land and treating it as if it's stationary, but his plane is now moving literally 1,000 miles an hour backwards somehow with the air. That's what I mean by pushed. What's the mechanism that makes him go in sync with the Earth?
Confused.
What's the mechanism that keeps the plane? What's the mechanism, the dynamic mechanism that keeps the plane in perfect sync at 1,000 mile an hour rotation as he's slowing down to land in the opposite direction? What's the mechanism that does that?
I think I misunderstood your example. Like, can you flesh this out a little?
The pilot treats the Earth as stationary, which we agree on, no matter where he goes, no matter where he lands. Right? He could just be randomly landing somewhere. But the plane has to be in
refraction and gravity.
The plane has to be in perfect sync with the rotation, even if it's 500 miles per hour faster than where he took off from. What's the mechanism that's making the plane in perfect sync with the Earth? In perfect sync, even though the atmosphere is not said to be in perfect sync, and you don't think it's being pushed backwards.
Refraction.
It's in sync enough that you make up that 500 mile difference, right? Like you can have again those. No, the air does. The air makes
up the difference.
So you have two places, right? One that's going 500 miles an hour, the other that's going 1,000 miles an hour, right?
Yeah, but you're saying that the air makes up the difference.
Wait.
The air only goes in one direction, but we have winds going in all directions, not just one direction.
Right. I got it. I'm trying to walk you through this. You have 500 miles an hour over here, 1,000 miles an hour over there, right? In both of these places, if there's someone there, what wind do they perceive in those locations?
It could be at varying winds. There's all kinds of variables. There's no way to know.
Okay, let's give a max. Let's say maximum 50 miles an hour. Okay.
In any direction.
In either direction, you choose.
And any, like northwest, south, anytime. Variables.
Absolutely.
All kinds of variables.
Yes.
Variables.
Absolutely.
All kinds of variables.
Yes.
Nothing predictable.
Yes. Okay. So he takes off from the 500 mile an hour, and he's approaching the 1,000 mile an hour, right? What does he experience in the plane, right? Because he doesn't experience the ground shifting underneath of him at 500 miles an hour because it's now going 1,000, right?
No, and he doesn't experience wind pushing him backwards to stay in sync with the Earth either.
Exactly. He experiences at most 50 mile an hour winds, right?
Yeah, which has nothing to do with rotation. Yeah. It's just winds in any direction.
It does. No, it does, because the rotation is the reason the wind is traveling the same speed as the ground.
No, the wind goes in all directions at any speed. It has nothing to do with the ground.
550 miles an hour, though, right? You're talking about a discrepancy of 500 miles an hour.
In any direction, the winds are variable that has nothing to do with the consistency of the rotation.
Can I ask
what
you a
I'm
question?
saying is, we've accepted 50 mile an hour. Hold on a second. Wait. We've accepted 50 mile an hour winds, and you're trying to find a discrepancy of 450 mile an hour.
No. I'm saying the discrepancy is in the ground. He's treating the ground as stationary. So now he has to have the idea of the conserved momentum that he took off with, that you had to begin with, like he's in sync because he was on the ground.
Right.
Now you have
Yes,
to
because
now
compared to the
justify
atmosphere,
that the plane's in sync with 1,000 miles an hour with no mechanism
yes,
of him being pushed backwards
I'm
with
telling you the
winds going in
mechanism.
all directions. And if he's landing, he's having to deal with a slightly different aggregate
Yes.
of difference between the more or less moving atmosphere. Even if you believe somehow there's a mechanism in the atmosphere to push him backwards, even if you thought that was
No,
possible,
no,
it's
no.
not
The
good enough.
atmosphere
The
is the
globe model is
mechanism.
not
The
good enough.
atmosphere is the mechanism. Because
Wait, why
No,
don't you
compared to the
that's what
put
atmosphere,
I
the
mean
Earth
by
is
push backwards.
large
stationary.
containers on the
That,
ground? Why don't you put large containers on the ground to prove this exact premise then, right? You have a large container on the earth, right, that's sealed off effectively, thus it would be what? It would be affected by the conservation of motion, right? You have air inside of this chamber, right? You leave it enough room that it has the ability to move. You do all of these different things, right? You even could try and take out the dynamicity of the weather itself away from this, right? And then you can try and prove this 50-mile-an-hour wind in all directions, right? But it won't happen, right? Because your
What are you
claim is
talking
that
about?
dude, what are you claiming?
real quick,
I'm
let me just
claiming that
clarify with him.
compared to the
We were going back and
atmosphere,
forth, but you're
No,
saying
no,
that the atmosphere acts like a wind, pushing him backwards faster to stay with the Earth, even though there's winds going in all directions. You're saying there's another
no,
wind that's pushing the
no. I'm
stay in
saying that the
sync because
atmosphere
it's
is
the
rotating at
atmosphere.
the same speed as the ground in
But it
aggregate,
has to
right?
push the
At
plane
most, you get
faster than where it took off from. So if it's pushing the plane, it's acting as a wind on the plane without the pilot feeling or noticing or knowing anything about this wind that's pushing him backwards. That's what I meant by push backwards.
exactly.
It has to be pushing the plane backwards at 1,000 miles an hour, even though he's got winds in other directions that he does feel, and those are dynamic. Those are real winds. You're saying there's a fake wind or a pseudo wind that keeps him in rotation backwards, even though he's landing and slowing down westward to land. That's what you
Exactly.
believe?
So, like, why can't
no.
they
I'm
make a
not calling that the wind.
wait? No. He was talking about right. You have the dynamic winds, right? Yeah, that
Right?
would be producing the 50-mile-an-hour differential winds in all directions potentially, right?
Yes.
Yes. Okay. So what we're simply saying now is that okay, why don't you control these variables a little bit, scale down your model, okay, then create exactly this 500-mile-an-hour conservation of motion that you claim exists in whatever direction, yeah, in the air, but do it inside of a controlled environment. Take away the dynamic winds, and then prove that this 500 mile an hour, right? Synchronization with the Earth's conservation of motion with this air. You could
Okay.
do
So
this
I
to
think we could do
scale.
this as a kind of thought experiment, right? And not to say that this is actually what's happening, but that it wouldn't be a contradiction if it were, right? So imagine winds just don't exist, right? Um, and imagine that the atmosphere is, as we claim, in absolute perfect lockstep, no fluid dynamics, no nothing, right?
Real quick, you don't actually
Perfect.
claim that though. You say more or less you don't claim perfect lockstep, by the way.
Yeah,
Yes,
more.
correct.
Yeah.
Right? So now we have an atmosphere that is in perfect lockstep, right? No turbulence, no jet streams, no nothing, right? If it's in perfect lockstep and the Earth is still, again, rotating 500 miles an hour over here in the north, 1,000 miles at the equator, if I take off in an airplane and I still use the air for thrust, right? I'm still pushing off the air to get to where I'm going. The atmosphere is still moving with the rotation of the Earth, right? So this trajectory that I have, to me, is going to have if the Earth is rotating, let's say, what am I traveling, north to south? So, hold on.
This is why you
The
need
Earth
a
is going.
connection to the conservation of motion from the Earth itself to the
Yes,
atmosphere,
yes,
right?
yes. We're presuming that. Yes,
You're
the
into a
atmosphere
tunnel,
is
you've got the
inherited the
conservation of motion
momentum of the Earth.
right, than the atmosphere, then if you went into an area where you were devoid of these things, i.e., the atmosphere itself, right, like a tunnel, yeah, let's say it was even a very large vacuum chamber, right, then you would still have the basis of the origination that created the movement of the air itself, right? In
Yes, but
concert
that's
with
different
the
though,
conservation of motion.
because right. But if you take away the atmosphere, now you're a ballistic object. Right? You're not
Well, then
pushing off
how
the
did the
air
atmosphere itself start to move in that way, you idiot? You don't have the
because it inherited the
antecedent.
momentum.
You don't wait there. You have the antecedent to claim how the atmosphere is moving in that way. Again, the atmosphere comes
Yes,
here first, right?
momentum.
The atmosphere is then thrust into this conservation of motion in the actual air itself, right? But you're saying once you take
I don't know
away
what
that
you mean by that.
itself, that the plane itself wouldn't be able to experience the same thing. So it's
No,
dependent
it wouldn't
on
have. It wouldn't
right?
gain those 500 miles as it's going south.
Well, the rotation of the Earth is still happening, or is it not?
It is, but the plane would have to more intentionally adjust for it as it
So
sees the
what?
Earth slipping from underneath of it.
So
It would still
what?
be able to
So
do it.
what?
So
What
that
does
would be a
that
different
matter?
situation.
Yeah, I know. I'm bringing up a different situation in order that you have a methodology in which you could take away the variables in which you're fucking arguing about in order that you could prove this ridiculous fucking claim, right?
Right. That's what I was trying to do when you interrupted me.
No, it wasn't. I just gave you the fucking idea, you retard.
Right.
Okay.
And then you
I'm calling
took
out the ad
some
homs.
weird tangent while I was trying to flesh that out.
All right, hey, go back to your scenario you were trying to explain because I didn't get it either.
Okay, so I'm traveling north to south, right? I'm starting at where it's rotating 500 miles, and I'm traveling to the equator. So the Earth is rotating to my left. Yes. Okay, so the Earth is rotating left, right? I take off. The air, which has no wind, again, no fluid dynamics, is also moving with the ground left, right? 500 miles where I took off. By the time I get to my destination, it will be moving 1,000 miles an hour from some outward reference point, right? Somebody looking at the Earth from the moon or something, whatever. By the time I get there, I will have been pushing off that same air, right? Forward, but that air has been moving left, just like the ground has been moving left. By the time I get to where I'm going, the ground and the air together have all been moving, gradually reaching 500 miles an hour faster than where I took off. Over however many hours that's taken me, I have gained that speed just by traveling through the air. Me, the air, and the ground have all been moving left faster and faster.
Yep, that's the kinematic concept. No dynamics to it whatsoever. It's just the
I mean,
idea.
I don't know what you mean by dynamics if it's not me pushing off the air physically.
Okay, well, let me just give you a couple hypotheticals that explain it. Maybe if you actually think that's true, then maybe it would work. It would be good for you to listen to some hypotheticals. Like, say there could be some kind of like, beam me up, Scotty. Like he could just be automatically beamed to the equator, right? The plane would experience a 500 mile per hour wind if it was like automatic transfer, right? Or if you personally were at a 500 mile per hour latitude and then you were just teleported to the equator, would you feel the difference in the wind? Because it wasn't gradual.
That would, I don't know. I think that would depend on how you're teleporting. Like, I can't really even make sense of that, really.
But do you get what I'm saying with like the way that you're doing, the way that you have to think of it is gradual, right? But if it was instantaneous,
yes, I think there could.
You would think there'd be some kind of a change that would be noticeable. Like another scenario, like if say you lived your whole life at the near the North Pole, right? Now you're said to be moving only like maybe 100 miles, 200 miles an hour your whole life, right? And then you were teleported to the equator that's said to be moving 1,000 miles an hour. So all of a sudden now your environment's moving at 800 miles per hour faster than where you've lived your whole life. Right now, you can think of it like if he took a plane ride there, he would adjust on the way. But if he was teleported or whatever, just in general, it's silly. But do you think that there might be a difference in the way someone feels by being 800 miles per hour faster? Suddenly.
No, not just because of that. Like I feel like there's a way you could teleport something where, yes, you could do that, like from a sort of singular reference. So
It's
all
just not. It's
rotation
not
sort of
supposed to be
canceled out. So
literal. I'm just telling that,
I
that
know,
there's
but
these things that
that's how
allow
my
you
brain
to.
works.
It's kind of like, yeah, it's kind of like the way that they explain it is with the gradualness. A lot of guys try to say, well, he's correcting for his course. He's got a ground path. Therefore, all the corrections he's doing to counteract the rotation, because the ground path leads him to this destination that's moving 1,000 miles an hour. So the pilot's actually creating this faster eastward vector that allows him to be in sync. But you're saying the pilot doesn't do that. Just the air eventually pushes the plane only eastward at a consistent rate enough so he can always treat it as perfectly stationary. That's what you believe, right?
Effectively.
Yeah. So that's the kinematic concept that has no dynamics to it, because the pilot deals with dynamic winds the whole time, and it has nothing to do with one wind that pushes him 500 miles per hour faster eastward.
I don't think that's the dynamic that they're talking about when they talk about dynamics versus kinematics. I think
I'm not talking
dynamic
about
they just
they
mean like
talking
an
about
actual mechanism.
I'm talking about real dynamics objectively. The pilot doesn't
Yes.
feel isn't it dynamically aware that the wind or air or pseudo wind, whatever you want to call it, is pushing the plane twice as fast eastward by the time he's landing. The pilot doesn't know that that's happening. That means there's no dynamics.
All that gets lost.
It's just a
It's not that
kinematic
there's no
concept
dynamics,
that you have to believe happens because there's no dynamics. So there's sensors
it's
on
just
the
that it's so
plane that would
minor
know
it
that
gets
that's
lost in all
happening.
that other stuff.
So
Yeah, I'm just saying it's so minor that it gets
the
lost in all
pilot
the other
knows
turbulence.
but the pilot knows there's 50-mile-an-hour winds in each direction all the whole time. He has no idea there's one pseudo wind that's moving him consistently 500 miles per hour eastward. You know why he doesn't know that? Because it's not happening and the Earth is
Because it
actually
gets lost.
stationary and people just pretend it all moves together. That's the point.
Well, that's a kinematic position if you want it, but
Oh, that's
how would we
you're the
determine which
kinematic
one is true?
position. That's a dynamic
They're
position.
both
Because if we're
kinematic.
acknowledging
No,
the
they're both
dynamics,
kinematic.
the dynamics say it's stationary, and that's the only way the
Nope.
pilot could treat it as stationary. That's the dynamics,
But the
my
dynamics
son.
don't say that. No, the
It would
dynamics
if
don't
there
say
was
that.
actual dynamics in your explanation. It would say, "Oh, well, it's just active. They just treat it as
There were.
if stationary." Your
Right.
model says as if stationary, as if they included the dynamics.
So whichever part of the model says as if stationary, I feel is the same part that says as if rigid body, as if no changing mass. Like that's just a way to simplify the
I
math,
thought you
maybe,
were
but they don't
against the
actually
rigid
say
body
as if
idea.
stationary.
I thought you were against the rigid
Exactly,
body
that's my
idea.
point.
You can't treat gas like
My
it's a
point.
rigid body, which is where we started from. You can't treat it like that.
I was talking about
You
the plane.
can
I was talking about
pretend
the
it's like
plane.
that. You can
I was
pretend
talking
it's
about the
like that,
plane.
but it can't dynamic.
I was talking about the plane.
No, the atmosphere has to act like a rigid body.
It does not. No.
Well, then it's not in perfect sync, and even those small variables would make a difference, even if it could push the
Not
plane
that big a
backward
difference.
500 miles per hour faster. The difference would not be a
500-mile
wind.
difference.
It would be even if it was a slight difference of a few miles an hour eastward, it's not a wind. It's
Exactly.
not. You can think of it
That's
like a wind,
what
but
wind
there'd be
is.
two things to deal with. If he was dealing with crosswinds in any direction, as well as a drifting thing to land on, like an aircraft pilot has to deal with, then we train all our pilots as if they're aircraft pilots, because there might be a slight difference in his eastward vector motion than the Earth's rotation, as well as all kinds of winds that he has to deal with. Dealing with just winds
Right, but
on a stationary
don't
Earth is different
separate.
than dealing with winds on a rotating Earth. There's two different
It's
things.
not.
You cannot
It's
separate
absolutely
them.
not.
No, you have to think there's
Exactly.
not.
You can't separate them. That's my whole point, is you can't separate them. If you have wind going 450 miles this way and you have another wind going 50 miles the opposite direction, that's not two different winds. That's one wind going 50 miles less fast in the same direction, right? That's the same
and if
wind.
you have a
can't
rotating
extract one
Earth,
from the other.
if you have an eastward rotating Earth that's completely separate from those winds, that's two things to deal with. We've cured you if you can realize that.
Things to do. No, it's not two things to deal with. How
It
fast is the air moving compared to the ground? That's the only question.
Yeah, and compared to a
ground, how
stationary
fast is it
ground.
going?
Listen, it's always compared to a stationary ground. The ground speed of the plane
Kinematically.
is measured by its relation to a stationary ground. If you were measuring the ground speed of an airplane to a moving ground, it would never even be calculatable. You wouldn't even be able to do the math, much less fly and land on it.
Moving compared to what?
Compared to
the
stationary.
air?
Compared to stationary, the way the
Stationary
pilot
what?
treats it. Stationary Earth,
No.
a lab frame.
Earth is
The lab
no.
frame.
Okay.
The
In the
absolute
globe
lab
model.
frame.
The absolute. What the fuck is that?
The lab frame is the absolute frame. That's how you know that
The sum
relativity
of the
is
universe?
relatively retarded, because you can't just like treat everything one reference at a time, one reference frame at a time kinematically and
Oh, you
say,
kind of
oh,
have
we're just
to.
going to mathematically deal with everything in this mathematical way, even though these reference frames don't add up. We just treat them separately, and it's okay to have the
They do add up.
contradictory reference frames, right? It's just a
No, they do add
kinematic,
up.
mathematical way of making your reality seem like numbers can solve reality to be this paradigm that I'm attached to, and I can just pretend the dynamics are included because we say
All right,
it's
get it
as
all
if
out.
stationary. As if stationary is the
Let me know when
dynamics.
you're done.
The dynamics is stationary. That's what it's saying. As if the dynamics were stationary.
Are you finished?
Dude,
Okay.
that
I don't know
was
what as if the
incredible.
oh,
That was
Jesus
incredible.
Christ.
10 out of 10.
Really? Jesus, you were
Yeah,
impressed by
yeah.
that?
I mean
Thank
that
you,
was
sir.
just he didn't understand a single word that he just said. Like not a single one. He couldn't tell you
Oh,
what
this is
kinetics,
Mordwan that's
kinematics,
going to
and
talk about
dynamics are.
nanometers in a minute and thinks
Yeah.
nanometers
No,
have
no, no,
something
no,
to
no.
do with arguments.
No, I just
It was
can you
incredible,
define the
though.
difference? Can you define the
Maury's
difference?
here. What's going
Can
on,
you
Maury?
define the difference for us between kinematics and dynamics? I'd be really impressed if you can do it off your own words.
Yeah, I think
The
we weren't agreeing on that at
kinematics
all.
is, you could have a kinematic explanation for things, but if you're
No, but
involving
what is a
all the
kinematic
forces,
explanation?
it could be all kinds of things. You could take in the mass of something, even though mass is usually regulated to the dynamics. The masses and the forces and all that has to do with the actual relationship between moving bodies, right? That's the dynamics, right? The real forces that would be involved. Kinematically, you can make it all work, subtracting and adding and multiplying and whatever you need to get to your final solution.
The final solution to the ball and the ramp problem.
Yeah,
One
to the
might say.
paradigm that the
Yeah, exactly.
atmosphere is moving the plane in sync with the Earth, so he could treat it as if, in quotes, it's stationary.
Your commitment to this argument is remarkable. I have to give you that.
Remarkable and fantastic
Yeah. And
and
kinematic
incredible, as you started
and
off with.
kinematic.
Trying to be
One
sarcastic.
might even say your argument is both kinematic and dynamic.
I guess if you want to put it on paper
Because
as well as make it make sense.
yeah. I mean, I think that you're a real force in the flat Earth space, driving change in sync
Yeah, now
with the
now it's
way
like
that the flat
I'm
Earth
gonna
is
try to
moving.
gaslight. I'm gonna try to gaslight him a little and act like I'm belittling him at the same time complimenting him, even though I have no point and no refutation to what he's saying.
No, I'm just here to summon the gang stalkers. That's the only reason I'm here.
Yeah, they all gang up because there's no answer to this one, and it debunks the globe so emphatically that everyone has to start ganging up on me.
I'll be
You
honest,
just,
I'm not even sure what you said half the time.
Well, we got to the end point where you were pretending the atmosphere would be moving the plane backwards, even though it's only supposed to be more or less in sync.
I don't think I agreed to that.
You couldn't separate it. You're treating the rotation as if winds are the same thing, which you can't get past. So you're done.
I mean,
You're done.
can you tell me what the difference is?
Yeah, one's winds, right? Moving the plane in all directions dynamically. And the other would be a rotation that the plane would have to be in perfect eastward vector tangential velocity sync with. It would have to be in such perfect sync that the pilot doesn't even have
I'm
any
not a wind.
idea that the plane's moving backwards somehow with the air as he's slowing down and land in the opposite direction. And there's winds going in all directions at the same time that he has to deal with. But somehow he has to believe in this pseudo realm of this narrative you live in that the plane's moving out backwards with the wind, the air's carrying it backwards without any mechanism or dynamic relationship to the plane that measures
Right,
its
with the
forward
wind or with
speed
the air?
according. The forward speed of the plane is measured according to the stationary Earth. If it was
I
a
think
moving
you're
Earth,
maybe
then he would
confused.
have to calculate the difference between his forward vector as well as the side vector of
You
the
sure about
eastward
that?
tangential velocity being 500 miles per hour difference, then where all those calculatable things go out the
Why
window
would he
when
have
you
to take
say,
that into
oh,
account?
we just think of it as stationary, so we don't have to worry about all those calculations. Oh, that's pretty convenient.
Why? Why would he have to take that into account?
Because it would be moving if that was actually happening. You'd have to take that into
Compared
account. The
to
reason
what?
he doesn't have to
Moving
is it's
compared to
actually
what?
stationary, and the only reason
Moving
he can
compared to
treat it as
what?
stationary is it's
Moving
freaking
compared to what?
stationary, dude. You sound
Moving
so
compared to what?
ridiculous, even though most of the world probably thinks they agree with you.
Moving compared to what?
What? Moving compared to stationary? What are you talking about?
Jesus fucking Christ.
Stationary, bro.
I know
It's
stationary. The Earth is moving compared to what? Not
The
compared to the
absolute
other
lab
model.
frame, obviously.
Okay, the absolute lab frame. Is the airplane in the absolute lab frame?
It depends on whether the kinematic
Are you
final
kidding me?
solution is implemented yet.
Oh, Jesus Christ.
Yeah, there has to be an absolute lab frame, and that's why relativitardism is such a thing now. People think there's no
Right.
absolute lab frame. It
So
has
you're
to be
telling
in
me that the
relation to something
airplane
else.
is measuring the rotation of the Earth from an absolute lab frame. Did I get that wrong?
No, the airplane doesn't measure any rotation of the Earth because it's stationary.
But if it did, it would have to be from an absolute lab frame, right?
No, if the Earth were moving, then the speed of the plane wouldn't be in relation to a stationary Earth. It would be in relation
Right. So
to
it would be
a moving Earth with a tangential gradient. That's the
okay.
difference.
So the Earth's frame and the plane's frame will be the same.
What?
So
Quick
would
question,
the Earth's frame
Why would
and
it
the
be the
plane's
same?
frame be the
If the Earth were
that's what
moving, it would
I'm
never be
asking
the
you.
same. You'd have to
Can
have
I-
a mechanism to keep the plane in sync with the faster rotation as it goes towards the equator. That's been my
So
point
I
this whole
gave you that
time.
mechanism.
quick
And I
question.
gave you that
No,
mechanism, which you
there's no
rejected.
mechanism. There's no mechanism. There's dynamic winds, but only a kinematic concept that beyond those dynamic winds, the atmosphere is also moving him twice as fast backwards, even though there's no dynamics that the pilot
And
can
here
even
we
detect.
return to
pilot
your
doesn't detect that?
misunderstanding of kinetics versus dynamics.
Okay, then you explain dynamics versus kinematics right now.
So kinematics just says you can explain a system two different ways and it mathematically makes sense. Dynamics says you have a mechanism for why it's one or the other.
Forces,
Man,
real
you
forces,
guys are
right?
confusing. Why don't you go with kinetics versus kinematics? The one with the M does not have mass in the equations. That'll be kinematics. So kinetics has mass in the equations, which means you got
Yeah,
forces.
you could call it kinetics instead of dynamics. That's a
Kinematics,
good
sorry.
one, Cyrus. Yeah, the
I may have misspoke.
kinematics has
What?
the kinematics has the M, even though it doesn't include the mass. Is what you're saying, right?
Right,
think
that's
it's
how
the
I
other way around.
memorized it. No, I think I got it right. The one with the M does not have mass in the equations, which should be kinematics. Kinetics
Exactly.
does include mass. I double check my shit. I'm not. It's been over a
Which
decade.
means it
So
wouldn't be
No, the kinematics
right,
is the
but
one
not
without the
having
mass.
mass
You're
means
right.
it wouldn't, which means it wouldn't be dynamic, right?
Yeah, you don't have the forces, bro. You don't have the mechanism. You can just claim a mechanism, even though you're
Okay,
still
so
just
I
doing the
was right then.
kinematics.
Right. So I
No,
was
you
right.
weren't right. You
dynamic
thought
means
there was a mechanism.
moving, right?
You thought that the kinematics included the mechanism. You could even use the M for the mechanism.
No, that's the opposite of what I said. Jesus
I got
Christ.
one
Regardless,
thing
you
for
were
this.
wrong. The
I
kinematics
got-
does not include the forces or the mechanism you would need to keep the plane in sync.
That's
The
Okay, I got a
kinematics
question.
is the
1
concept.
second. This is
Christ
what
on a
you.
cross.
1 second,
Go ahead.
Globers.
You
Okay,
talk.
don't
I
lose
gotta
your shit.
fucking-
Okay, I think this is what you Globers should be asking. Okay, Dave, New P, can a plane actually fly on a globe? In your opinion?
Oh God.
Not if it's treating it as
Went from
stationary.
bad to
If it was
worse.
flying over a globe,
no.
it wouldn't
No,
be able to
you work it
assume
out.
that it's landing on it as if it's stationary. It can't be
But
as
could-
if stationary and actually be a globe because it's not in the same reference frame. It's
But
detached. That's why they
could a
say
plane?
conservation of momentum from being on the Earth keeps it up, but then they have to change it to the air when you get to a higher tangential velocity, and that doesn't even work either because there's no mechanism.
Okay.
It's just an idea.
Well, there's no mechanism is like implying or importing that they're not using anything to correct anything, right? So my question for you,
They
however,
don't even have a claim.
UP, 1 sec. Like, yeah, do you think that planes could actually fly on a globe with this kinematic versus dynamic sort of interpretation?
Not if it's treating it as stationary. If it was moving, it would be a completely different scenario.
So
because
if
they don't even claim a
were-
lockstep atmosphere. They claim more or less, and more or less wouldn't even be good enough if it's treating it as
It'd be
stationary.
plenty good.
And there'd have to be a mechanism that's pushing the plane with no dynamics, even though there's dynamic winds pushing it all over the place.
So presuming that they did account for it, do you think they could fly on a globe? I'm just kind of curious as your take
If
on
they
that.
did account for it when they landed, they would have to either be facing directly east or directly west, and the runway, the landing strip, would have to be going along with the rotation. And if they landed east, they'd have to speed up to keep up with the rotation when they landed. And then if it was going west, they would have to slow down so that the landing strip didn't end too soon. They would have to slam on the brakes.
Okay, so I was right earlier when I was
so-
saying you're
so
expecting
question.
1,000-mile-an-hour winds at the landing point. That's so stupid.
And nothing to
Okay,
do with
but-
wind.
okay,
I'm talking
but
about the
UP,
rotation of the
UP.
surface
It would have
only.
to be. That's what
The
you're
rotation of the
suggesting.
surface is what we're talking
That's
about.
what it would
You keep
have to
conflating
be.
it with no.
Gentlemen,
It's the difference, dude.
gentlemen.
The winds and the earth surface of the earth moving the plane would be two different things. That would cure
I
you
wanna-
if you realize that.
Not.
I
It's
want to
not.
know, in your interpretation, UP. So these, like, what's going wrong? Essentially, what would you expect to see the planes be doing if they weren't like? So they say that they're not accounting for it. They say they don't need to, but they should. In your interpretation, I just want to understand what would be happening with the plane, and how would it be trying to land, or what's actually happening? Does it start like rotating upside down all of a sudden, and then you'd expect it to crash? Like what would you be expecting to see if they?
You would expect the wheels to snap off.
Yeah,
Well, I mean,
if it
no,
was
but the
if it
plane would
was
be
moving
coming in the wrong
eastward at a
direction or
different,
something.
if it was
I don't
moving
know, like-
eastward, we measure it by eastward tangential, and the globe claims the globe claims that it's an eastward tangential velocity of 1,000 miles an hour.
Yeah, but so my question is primarily, what would you expect? So they're not accounting for it. What would we expect to see in the plane from your interpret? Would it start rotating upside down accidentally because they're not accounting for it? Or like what would start occurring? Like, how would you expect the plane to go down if they can't do it, right? And you've got this two dynamics, like two environments that it's set within. They're not accounting for it. What would you expect them to be accidentally doing, or like how would it go wrong?
Well, according to their model, right, it's an inherent contradiction because they're saying that the plane treats it as stationary, even though it's not attached to the Earth any longer. It's in a separate reference frame because we have the inertial and the non-inertial reference frame. So they acknowledge that, but then they treat it as if it's the same reference frame, and the pilot could treat it as stationary. So there'd be all kinds of stuff happening if it was actually moving.
Yeah,
because it wouldn't be moving backwards
what?
as it's landing. Is facing westward. It can't be moving backwards at the same rate as the Earth without a mechanism to move it backwards as it's slowing down to land in the opposite direction.
I want to know what, like, so there's passengers on that plane, right? And you've got some globe guys that are, depends on the way that you want to take this, but they're either accounting for it and they don't need to, or they don't need to and they are accounting for it. So what would
They're
you
not
expect?
accounting
Like, you're
for
a
it. They're not
passenger
trained
on
to
that
account for it.
plane. What's the experience of the passenger on the plane? Like, does the plane begin to slowly turn upside down or something? Or does
That's
it, like,
another
sort of the
point you could
speed is
make.
just
That's another point you could make about being upside down if we went around the world. But regardless, you could just say that the center of gravity makes that even unnoticeable or whatever. I'm saying all the arguments about the plane, the curvature and all those things with the pendulous vanes and all these other excuses, you could maybe get away with thinking, oh, that makes sense, pendulous vanes, or maybe there's all these, maybe like, somehow the curvature doesn't really matter, and all these other things, maybe you could convince yourself of. But when you deal with the actual reality that the pilot only treats it as stationary and it's in a separate reference frame, and you'd have to believe somehow the air carries it consistently backwards as it's landing facing westward at 1,000 miles an hour without any kind of mechanism or notice on the pilot's part that he's being pushed backwards. There's no wind. You could call it a pseudo wind and just pretend it's there, but that's not a real mechanism, bro. That's just a kinematic concept.
No, it's
There's no
Coriolis.
actual
dude.
dynamic wind. There's no dynamic.
Coriolis kiff. It's the Coriolis.
Plus, the
Keeps the plane in check.
The plane would need Dyson ball wheels to land sideways if it was on a spinning, wobbling monkey ball, right?
Nice.
Okay, can I address that real quick?
Mordwan's getting it, even though he's kind of making fun of it at the same time.
Right.
Yeah,
So
yeah.
let's work through that for a second, because that makes zero sense to me. So somebody at the landing point, right, that's going 1,000 miles an hour. Let's say they're perceiving a 50-mile-an-hour wind, right? A little gusty on this day. You're telling me that the plane is approaching this point, and the ground is shifting under it at 500 miles an hour compared to where it took off. Is that the implication here?
That's what the globe claims. It's not me claiming it. That's what the globe
It's
claims.
very much not what the globe claims. That is absolutely not what the globe claims.
The globe claims it's
At
moving
no
500
point
miles
did
per hour faster.
compared to the plane? Is that what the globe says?
Compared to where the plane took off from, the globe claims that where he's
Right.
landing at the equator is 500 miles per hour faster.
Correct. How fast is it going compared to the plane?
The plane's only moving 100 miles an hour forward the whole time, west southwest.
Okay. And when it gets
So
there,
now you have to believe
what does
that
it
it
observe?
picked up. It was starting out moving at 500 miles per hour eastward, yet only going 100 miles an hour forward west southwest.
Huh?
He gets to the equator and he lands in a random spot. You're still believing now that not only was he moving 500 miles per hour eastward when he started off, now he's moving twice that fast backwards at an angle so that he could treat the
I don't know
Earth as
what
stationary
backwards
without a
means.
mecanism. Backwards is he's
Did the
facing
air pick
west.
up that same
Wait,
rotation?
listen, he's facing
Did the air
west.
pick up the same rotation?
Right. You said you don't know what that means, so I'm going to explain it. If he's facing west southwest when he's flying and when he's landing, then there have to be somehow 1,000-mile-an-hour mechanism moving the plane in perfect sync with the rotation of the Earth at the equator, so the pilot doesn't have to worry about anything. He can just treat it like it actually is, stationary.
The air is the
Hey,
mechanism.
is it me or did Dave kind of sound like Witsit there for a second? He had the same kind of cadence, you know,
Well,
like
he
kind of
was
like
meant
the
to be
rap.
gone
same
about an hour
argument.
ago.
Talking
He's
about
sticking around,
conservation
though.
momentum. Is that what we're talking about?
We're talking about the difference in the
certain cadence,
conservation of
right?
momentum from where the plane takes off. There'd be like 1,000-mile-an-hour ground movement at the equator, where he took off at a 500 mile per hour latitude, where he'd only have 500 mile per hour pretend or pseudo, eastward vector conserved momentum. But that wouldn't last long, even if he did have it. But now he has to be moving twice as fast to treat the Earth as stationary at the equator. What's the mechanism that pushes the plane back as he's slowing down to land in the opposite direction? The air is not a mechanism. You could think of it
All
as
that shit.
if
Oh
you
my
had
God.
a wind
Okay.
actually pushing him backwards, that would be
Diagram.
different. We don't have no dynamic
It's
wind.
not wind.
We just have a kinematic excuse.
It's only 50 miles an hour wind. We agreed, right?
Well, then where's the 500 mile per hour wind moving him
He
backwards
took off at the
faster than
equator.
where he took
It's
off
not
from?
the wind. It's the air. The air, and it is also moving 500 miles an hour faster.
So the air pushing the plane is not a wind. What do you call it?
It's the plane pushing through the air.
Okay, so it's pushing through the air plus being carried back by it.
No, what do you mean being carried where?
It's being carried at
what is
1,000
the
miles
air
an hour to
doing
be in
over that
perfect
spot?
sync. The air would have to carry the plane, right, somehow backwards at the perfect
Wait, is he saying?
speed.
Is he saying that something can move without being pushed?
He's saying that the air carries the plane without it being any kind of dynamic force.
The
Yeah,
dynamic
that's what it
force
sounded
is
like
a
to me,
thrust
too.
of the airplane. That's the dynamic
But
force.
isn't-
The
No, the
medium
thrust
it's
of the
traveling
airplane is the
through is
opposite
traveling
direction.
500 miles faster where he's landing than it was where he took off.
No, he's traveling the opposite direction 100 miles an hour, and then he's slowing down to land facing the opposite direction. It has nothing to do with the thrust of the plane.
What the fuck maneuvers are you talking about? What is he? I'm
Talking
just
about
going.
the
I
pilot.
just have
The
him going
pilot has
north to
no
south.
idea. The pilot just
I just
flies
have him
100 miles
going
an hour
north to
forward.
south. Right. Yes, forward. He's going due south. Right, north
But
to south. He
the
took
air
off where the
carries
Earth is
it back
rotating 500
500
miles.
miles per hour faster.
What do you mean back? It's
Well,
side
if
to
he's
side in
facing
this
the
scenario.
opposite of if he's facing the opposite way of the rotation, then it would have to be moving
Why
the
is he
plane
facing the
backwards.
opposite way?
He's going
No,
west southwest
no.
the whole time, and then that wherever he decides to land,
Can we just do
chooses
north to
west.
south?
He's facing west when he lands. So now he's
Can we just
facing
do
west.
north
Now the
south?
plane
Because
has
I don't know what the fuck you're adding
why?
into this.
Because it's
It's
too hard to
overly
imagine.
complicated.
It's too hard to imagine the
Yes,
air
because I don't know what
pushing the
you're
plane backwards.
imagining in your head. What is this?
I don't
Can
blame
you
you.
draw it
It's
for
really
me?
hard
I don't
to
know what the
imagine
fuck
it
you're
working.
talking about. He took off where it's 500. It's going where it's 1,000. That's north to south. He's also going
East
west
and
now.
west, bro. East to west. The planet supposedly is rotating westward, correct?
Correct. Supposedly.
No, I mean eastward. Eastward. It's an
Sure.
eastward rotation, right? The pilot is aiming the plane westward. So the air would have to be carrying the plane backwards eastward at the exact same rate as the Earth, without a mechanism, just an idea that it's in sync, even though there's winds going in all directions dynamically that the pilot does have to deal with.
So you have the pilot traveling the opposite direction of the rotation, right?
Yep, at an angle west-southwest towards the equator where it's 1,000 miles an hour rather than 500 where he took off from.
Okay, how is that a better? All right, sure. So what's they're saying he's traveling the opposite direction
100
of the
miles an
rotation.
hour forward at west-southwest at an
Right.
angle, but he could be doing all kinds of loops and going all over the place. He could go up to the North
Why
Pole,
not just
down to
have
the
him be
South Pole.
straight?
Somehow, whenever he gets to where he's deciding to land without a ground path, just a joyriding pilot, right? He's always going to be able to treat that clearing that he just randomly decides to land in as stationary. And somehow the
Right.
air magically is still keeping him in this vector of eastward, going 500 miles per hour faster than where he took off from. So the conserved
Not
momentum has
magic.
nothing to do with it. It has nothing to do with the forward thrust of the plane because he only went 100 miles an hour wherever he felt like the whole time. Now he's got somehow the plane has to be going at 1,000 miles an hour in such perfect sync with the rotation of the Earth that he can just treat it as stationary still. Where's the mechanism that keeps
Not
that
perfect
happening?
sync.
It has
Yeah,
to be
it's
perfect
the
sync.
air.
It has nothing to do with the
The air is
winds.
doing the same
Because
thing.
if he was dealing with the
No,
rotation of the Earth
but it doesn't have
moving
to
at
be
a different
perfect
rate
sync in the
eastward,
sense that they can
don't
adjust
get
for
loud.
winds, right?
Don't get
And
loud.
that's
This
not
is
a
a
big
fact.
problem.
This is a
I
perfect.
can't
This is
speak
a
if you don't
simple
let me
fact.
to
Don't get
fucking
loud
speak.
because
Don't
I'm
get
saying.
loud.
Don't get loud.
It's getting scrappy.
All right, somebody else can
The
talk to
truth
this
is,
guy. He just doesn't want
manufactum.
to hear what I have to say.
Manufactum just tapped
Chucky,
out.
the reality
He just-
is that
Okay,
if he was dealing
could
with
you
a different.
explain this?
on the ropes.
He was dealing with an eastward rotation that was different than his plane's eastward rotation, as well as winds. That'd be two things to deal with. That's a simple fact.
It's not two
You can
things to deal
you
with.
can just pretend it's the same thing, but it would be two things rather than one. Like an aircraft pilot has to land on a moving
The only
surface,
thing you have to
right? You have
contend
to be
with
trained
is
to
the
land on a
wind,
slightly
and
drifting
all that
surface,
is
which
to
would be
translate
which
is
would be
simply
the difference.
the
If
difference
the atmosphere is only
between
more or
the
less,
ground and the air. That's
would be a
all that
slightly
is.
different. More or less would be slightly different. Aggregate
Yeah,
means
that's a
slightly,
wind.
means
Planes
almost
deal
the
with
same.
wind all the
If you're gonna
time.
scrap, keep the gloves on.
Slightly different does not matter at all.
You would have to believe that because otherwise you wouldn't believe in the globe.
No, it's just how physics works. Planes
Oh,
Yeah.
you
deal
just
with
can
winds.
estimate
It
things?
Explain
doesn't
this.
matter.
Oh, everybody, here's the pilot speaking to the people on the plane. We're going to be more or less eastwardly in sync with the
They're telling
rotation
me
of the
that
Earth,
any
and they're
amount of
telling me it
wind,
doesn't
any
matter.
light breeze,
So it
and the
might be
pilot
that the
shits his
wheels break
pants and
off
gives
just to
up,
give you a
goes
little
home
warning.
and stops being a pilot. Is that what you're saying? With a straight face, you're going to tell me that's all it takes for a pilot to just oopsie goof and not know how to fly a plane?
Oopsies.
No, now you're trying to strawman it. The pilot treats it as stationary because it's stationary. He has nothing to worry about, bro.
Because minor winds don't matter. They can
And there
fly
you
with
go again.
minor winds.
Confusing winds with rotation. Otherwise, you wouldn't believe in the globe.
I'm not the one confused here. There is no wind when you're considering only the rotation. It's all rotating at the same speed.
No, you said more or less, or aggregate, or whatever estimation word you
Right,
wanted to
more
throw in
or
there.
less means minor winds. That's the
No, it
more
doesn't.
or less.
No,
Winds,
that's
that's
what you have
all
to
that means.
believe.
Everything
Okay,
else
gentlemen,
is in aggregate.
gentlemen,
For fuck's sake,
gentlemen,
what is so difficult about this?
Because there's no
gentlemen.
mechanism pushing the plane to be in perfect sync, as well as winds dynamically pushing him in all directions. You can't separate those two. You could think of them as
It's
the
the
same
same
and
mechanism
different at the same
causing the
time,
air
but
to
you're
be
the one
moving
that's
at two different
confused.
speeds. The air is
Okay.
moving 500 miles over here, 1,000 miles over there. Same mechanism that's moving the air at different speeds is moving the plane at different speeds. Exact
No, it's
same
just an
mechanism.
idea. We pretend that the Earth is moving 500 miles per hour here, so we pretend the air is moving 500 miles an hour. We pretend it's moving 1,000 miles an hour to the equator, so we pretend the air is also moving at 1,000 miles an hour at the equator and pushing the plane to be in sync. And there's dynamic winds pushing it in all directions. And it doesn't matter if he lands on a surface that's not really in sync, but it's partially in sync. We can just think of it as winds. It's not the same thing,
That's
but
in
we can
sync.
think of it that way and keep our paradigm intact.
No, it's not thinking of it. That's what they're defined as.
No, kinematics and
And if you
dynamics
don't
are
think
different.
that's
You
what's
should look
happening,
into
that's
it.
absolutely
Manny,
fine.
Manny,
But you have
Manny.
yourself a hypothesis. Now go out and fucking prove that shit.
But
No,
Manny,
you
do
need
they
to
treat
prove
it?
that
Do
treating
they
it as
treat it as
stationary means
stationary?
that it could actually be moving. If the
I
ground
did.
speed, the speed of the plane is measured against the stationary Earth, and
My
the
threshold
treating
is
it as
super low.
stationary,
If that's what I have to
you have
prove,
then it's
all I
the
have to prove
onus
is
is
that it's
on
not
you
contradictory,
to
which I
show that he could
already
be
did.
treating it as stationary,
Ladies,
even though it's
one
Everybody
at a
moving
understands
time.
it,
1,000
but you
miles an
can't
hour.
wrap your head around
Let's
it.
not do
That's
audio
not my
chaos.
problem.
Let's have a conversation.
I would have loved to, but he's incapable.
Well, I mean, you
You're
are trying to
projecting.
converse with him and then pretending that he's not capable. So, like, look, he's very
And
energetic about the
sorry,
subject.
what
So
choice did I have?
what choice? You've got plenty of
There's
choices.
nowhere to
Your
Ryan.
choice
interject
was
with
give
my
up your
opinion.
stupid paradigm or relax and just listen.
Yeah, I'm not going to be preached at. I'm sorry.
Well, no, you
You
couldn't
don't.
provide a mechanism. You just had a kinematic
I
idea that
did.
you called dynamic.
No, I did provide a mechanism.
Just saying you did doesn't mean you actually did, because you don't know the difference between
Man,
wind
you
and
got
rotation.
smoked.
New P, did you
A
did you have
medium.
something that you were meant to do and you chose to be here and you're just loving it?
Yeah, I should have gone a long time ago. I'll let you guys take over. Good night.
Oh, sweet
Oh
mercy.
no. That was fun.
Damn, that
Manny,
was
I
Why'd you
get
kick
worked
him
up
out,
about these
Ricky?
things.
Just
I didn't kick him
could you
out.
Why'd you
explain
kick him
this?
out? You bullying him?
I reminded him that he did say about an hour and a half to 2 hours ago, I'm going to leave real soon, and he's still
Ricky's a
hanging.
bully.
So, yeah, totally. I just reminded him what he's like, what he intended to do, and he got sucked into the comment because he's passionate about it, which I don't mind. It was good
Oh, he
fun.
likes the topic. It's fun to
I-
listen to him, though. I think he did good.
Booked a flight today, Heathrow to JFK. Headed west-southwest, cause there ain't no better way. Gonna find that old Coriolis, they say she's hidden in the winds. But that just can't be if we rotate east, tangential gradient. Hidden in the winds, Coriolis must be hidden in the winds. But the earth ain't moving faster with the further south we've been. And we never could land safely with that tangential gradient. And we all know every pilot treats the earth as motionless. So to think it must be moving is just insane, you must confess. But please don't get offended if this song makes too much sense. Just thank God that landing's easy with no tangential gradient in the winds. They said she'd just be hidden in the winds. But the earth ain't moving faster with the further south we've been. And we never could land safely with that tangential gradient. So here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, don't worry about rotation, cause we ain't on no damn globe. So here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, don't worry about rotation, cause we ain't on no damn globe. Hidden in the winds, Coriolis just ain't hidden in these winds. And the earth ain't moving faster with the further south we go. So thank God we won't be crashing when those wheels hit down below. Hidden in the winds, there ain't no Coriolis hidden in the winds. And thank God it's stationary, or we never safely land on a surface that is moving with a tangential gradient. Yes, here's a lesson for who's listening. It's dynamics that are true. No kinematic concept could ever substitute. So the next time you are flying, no matter where you go, Don't worry about rotation, cause we ain't on no damn globe. Hidden in the winds, Coriolis just ain't hidden in these winds. And their earth ain't moving faster with the further south we've been. And thank God we won't be crashing when we touch down at the end. And thank the Lord, Earth is stationary, or we never safely land on a surface that is moving. There's no tangential gradient.